Hi Spring fans, it's kind of a bummer that we couldn't do this together live in person, but I hope that the time comes sooner rather than later that we can, safely and without the virus. But for now, anyway, I'm happy to be before you in any capacity, even online. So thank you ever so much for having me. Today, we're going to talk about building applications intended for production. Remember, the goal at the end of the day is to get software into production as quickly and safely as possible. We want to decrease the cycle time and increase velocity. The reason we want to do this is to learn from our deploys, to iterate based on what we've done and what we learned. And this idea that speed allows faster iteration isn't new, right? In the military, the American military, and I'm sure others as well, they have the concept of the OODA loop, O-O-D-A, observe, orient, decide, and act. There are some interesting implications from this loop. In the theater of war and an aerial dogfight, the faster planes are better positioned than the more heavily armed planes. And the same is true in the context of microservices, without the death, of course. I mean, at least one hopes, right? The faster you can respond to change, the better. So the goal is a business outcome, not a technical one. Everything we're going to talk about today, microservices, continuous delivery, agile, continuous integration, they're all to better improve our business's ability to deliver and to iterate. And with that goal in mind, there are some natural consequences that fall out. We want to start with a large picture of going quickly and safely, and we'll see that that informs our technical decisions. If we start to look at the code base, the larger the code base, the larger the team, the longer it takes to stabilize, integrate, and deploy to production. So okay, naturally, the goal here is to go quickly, so we decompose into smaller code bases organized around small chunks, like a bounded context. That's a microservice. This way, there are fewer people and it takes less time. Awesome. Now we've got each team moving independently. They have autonomy. This increases our throughput. Now you can have multiple concurrent ships shipping to production, sailing to production at the same time in your organization. Your efficiencies improved dramatically. But now you're also building a distributed system and shipping it to production, which these days, as often as not, is Kubernetes, which is itself another distributed system. Distributed systems fail often. So you've got to make your application be aware of those particular corner cases and to make sure you don't run afoul of the risks of the fallacies of distribution. Things like the idea that the network is infinitely fast or always available, etc. These are problems, and if you don't address them, you're not going to enjoy your experience. You also need to handle the requirements inherent in building on a distributed system like Kubernetes itself. So in this deep dive, we're going to do a lot of things, but most of them, almost all of them really, are so that we have an easier time of building software that's intended for a volatile, dynamic, but powerful platform like the cloud, like Kubernetes. Let's dive right into it. First things first, let's dive into some basics, some absolute fundamentals that you're going to need to know to be able to work with Spring Boot. Before we can start building services and systems, we need to know how to build basic apps. Well, I'm excited that we're going to do this workshop together. Let's get started. In this first section, we're going to look at how to build applications in general using Spring, right? Just the basic stuff here. So let's get going. We're going to start by going to my second favorite place on the internet. Obviously, my first favorite place is, yeah, you guessed it, production. But my second favorite place, of course, is start.spring.io, because if you haven't begun your journey to production, you can begin it here at start.spring.io. So what we're going to do is we're going to go and build a new service. Here at start.spring.io. We're going to call this customers. We're going to use the latest and greatest version of Spring Boot. We're going to use the latest and greatest version of Java or Kotlin or Groovy. I'm going to use Java 17 because I can. It's the right thing to do. No, you know what? Actually, I'll use Java 11 because we're going to look at native images later. But if you can use Java 17, you definitely should use Java 17. And when GraalVM is using and supporting Java 17, yeah, this is going to be the thing I select all the time. In fact, I select it most of the time anyway, but for now I can't. Okay, so we're going to build an application. It's going to use the reactive web support, R2DBC, which is the reactive relational database connectivity support. We use H2, which is an in-memory embedded SQL data store. We're going to use, what else are we going to use? We're going to use Lumbuk, which is a compile time annotation processor. And I think that'll do it for now. Let's go ahead and hit generate. And open this up in our IDE, UAO. Okay, brand new project. Let's open up the customer's application. And you can see it's just a public static void main application. It's trivial. There's nothing in there except for the public static void main and at Spring Boot application. At Spring Boot application, it tells Spring Boot that this is an application, and we run the application thusly. There's no web server to which we have to deploy, etc. So that's convenient, right? Now, I want to build an application that has data. So I'm going to create an entity to describe our data. It'll be an entity of type customer with a field called name and a primary key called ID. I'm going to be using R2BC, and that's a reactive relational database connectivity abstraction for which there are implementations supporting, among other things, Microsoft SQL Server, H2, Postgres, MariaDB, SAP HANA, Oracle, all the different things you can imagine. There's implementations for that. And I like to use Reactive APIs because it buys us three big benefits. Three big useful use cases, right? The first of which is ease of reuse, that is to say, ease of composition. I can easily take anything written in reactive streams and compose them. And this is very convenient because if you think of all the different ways that we have to glue together different APIs in a non-reactive world, right? If you're doing WebSockets versus messaging versus REST versus RSocket versus gRPC versus GraphQL versus whatever, it's a different API each time. Not just for the production of those endpoints, but for the consumption, which is what I'm talking about here, right? If you're trying to ask a Kafka broker for messages, the way you ask it to asynchronously deliver messages to you is quite different than the way you would do that for RabbitMQ or for JMS or for whatever. And that's because there's no easy default sort of de facto type that everybody can use to say, hey, here's a stream of values that are unbounded. Please give me the values as they arrive and when they arrive, right? And so each API has to reinvent that particular paradigm. Not anymore. With reactive APIs, you have one particular type of stuff. This one particular type of stuff, it assumes that everything is asynchronous by default. So you can treat it like synchronous. You can actually schedule everything on the same thread pool, and thus it's serialized. But what you want is to assume everything is asynchronous, because that means you get a little bit of flexibility. You can actually start the request on one thread and finish the request on another thread, which is very useful if you have a smart runtime that knows about which threads are being used and when they're being used, and can do that work for you. And that's the next benefit, which is that you have a scheduler which moves work from one thread to another. This is great because now each thread is used as fully, as completely as possible. It's never just sitting there idle, waiting for something to happen because you're stuck in a wait loop, blocking for the next byte from an input stream. Instead, you would have used an asynchronous NIO channel to get the data, to ask for the data, and then wait asynchronously for the data to come, right? And in that meantime, while you're waiting for that data, you're not sitting there blocking using that thread. That thread is freed up and something else can be put on that thread, right? That's the function of the scheduler. It makes your services more efficient, more scalable, right? This is very useful. The other benefit that we get by having that unified type, that one kind of stuff, is that we now have a natural place in which to interpose things like, retries and routing and rate limiting and all these sort of patterns that we care about to make our API interactions more durable, more resilient, more safe. And so these three benefits come for free with reactive APIs. I love this, even as somebody who works on the Spring team, because we have a number of different APIs that we created and that are quite popular, that people use, that came before the introduction of reactive APIs that serve some of these use cases. There were separate APIs. You had to use separate things, like, for example, retries, right? Well, that's just built into Reactor now. Now every API can do retries. It doesn't have to be just a particular workload. So, it's a really nice win. You get a lot of things for free. And the best part is you can throw away a lot. You can throw away those distinct APIs that we had before because they're all just part of Reactor. And you can throw away all the different paradigms in your head that you had to learn about to get data in and out of different types of services, right? That's so much of the problem of microservices. So much of the tedium of microservices is that integration. And if that goes away, if that tedious adapting one type of stuff to another goes away, then life becomes simpler, much simpler, right? So it's a win-win-win all around. It's simpler, it's faster, it's more scalable, it's also easier, right? Okay, so we've got a basic entity. We're going to persist this into the database. We'll say this is a repository. It's going to extend the reactive CRUD repository, man it with an integer primary key. And we're going to use that to write some data to the database. We could do it this way. So we'll create an initializer, implement the methods, and we're going to inject the customer repository. And we're going to inject that into the constructor, thusly. And we're going to write some names to the database. So flux digest, and I'm going to go through some people that are on the Spring team. I'm creating a reactive stream here of type flux, okay? And I'm going to create a string literal, and these are people that are on the Spring team. So Mark, Madura, Dr. Sire, Yushin, Stefan, Stefan, Olga, Violetta, and I don't know. Oh yeah, me. Oh yeah. Okay, good. All right, good. So let's take some names. I'm going to map each name into a new customer, and that gives me a stream of customer object, but they haven't been persisted yet. So what I need to do next is I need to turn each one of those and write it to the database using the injected repository. So I'm going to say flat map this.repository.save C. And the reason I'm using flat map is because the result of this is a stream of customers. If I don't use flat map, if I use map, I get a stream of mono of customers. That is to say, a stream that can contain multiple values, which is a publisher, containing a stream that can contain a single value, called a mono, which is also a publisher, which contains a customer. So think of flux and mono as like completable futures. They're both things that can resolve asynchronous values for you. But mono can only resolve one value at most, and flux can resolve 0 to n, where n is potentially unbounded, okay? Which is, that's not the same with completable futures. But I don't want two reactive streams. I don't want two asynchronous streams of values. I just want the innermost one. And the reason I have two reactive streams is because the result of save is itself a mono of customer, right? So what I want is to unpack or quite like the COVID curve, to flatten that inner reactive stream. So I use flat map, okay? All right, so I've got now, what do we have here? We should have 8 names, right? There's 8 different names I'm going to write to the database there. And that could work fine, but I have to run this. If I run this, I need to subscribe. And the reason I need to subscribe is because what I've just defined is a pipeline. That pipeline it's how water will flow through the pipes. It's not water itself. That is to say, nothing happens. It's inert until I subscribe. So save.subscribe is what actually turns on the water. Okay. Okay. So there we go. That'll work. Remember, I've got an in-memory SQL data store on my local machine, but this will work just fine. So let's go ahead and run this. Okay. Okay, something's gone terribly amiss. What have we done? Look at those stack traces. It's fun. This is fun. Not implemented. Oh, because I don't have a table. It's saying, hey, I can't inject anything to a SQL table that doesn't exist. And I say fair point. So what we're going to do is we're going to create a schema here, a schema.sql. We'll say create table customer ID serial primary key name varchar 255 not null. Okay, and then we're going to restart this script. That schema.sql will be automatically run when the embedded SQL database is used, right? So if it's H2 or MySQL, sorry, if it's H2 or HSQL or Derby or something like that, then that'll get used. If not, it's an option you can opt into, but it's not by default. So there's our 8 records. What we need now is our endpoint. We need some REST endpoints that we can use to get that data. So one way to do it is to create a customer REST controller. This is a Spring MVC controller by default. I also want the response body. There's an annotation you can use called @REST controller, which does the same thing, but these days I tend to do that. And I'm just going to return all the customers, right? So, and I'll do that by injecting customer repository. All right, good stuff. Okay. return this dot customer repository find all, and voila, restart. And this is just an HTTP controller. It's a controller for REST APIs because it has a response body, but by default, this would get you an MVC controller. The reason I mentioned that there's a distinction is because we have a lot of different types of controllers. They all use the same annotation, which by the by is not actually in the HTTP package or anything like that. It's always been a generic Spring Framework annotation, a stereotype annotation in the UML sense, and we'll see that that applies to a lot of different things here. Okay, so we've got our endpoint. Let's go ahead and see what we get. So localhost 8080/customers, and voila, look at that. There's our records, our data. Okay. Now I don't need to, we don't need to reinitialize this in code. That actually can be done in the file as well. So data.sql, and I'll just say insert into customer name values Mark, Madura, Dr. Sire, Yushin, Stefan, Olga, Violetta, and yours truly. All right, good. So there's our basic initialization script, and I can get rid of this. Okay, so really our API, our REST API, is 27 to 55, right? So 25 basically, lines of code. Not even really that. I could have used one annotation here. I could have used Lombok to synthesize the constructor. I mean, there's lots of opportunities, right? It gets down to the point where it's very hard to be more efficient than this, even in other languages like JavaScript, right? It's just, we're so concise at this point. What's the point in trying anything else? Okay, so there we go. There's our simple API. Same amount of data, right? It's an embedded in-memory SQL data store, but it's still got the data in it. Okay, good. Now we've got our simple API. We've looked at the basics of reactive programming, right? And I'm using Java here, right? You notice that we're not wasting any time here in my code. I'm not actually setting anything up. I'm not doing anything to install the web server. There's no deployment descriptors. There's nothing like that. I've just got a very simple application that does what I want it to do. And the reason that we have that is because of something called auto configuration. So when Spring Boot starts up, it looks on the class path for a text file called spring.factories, and it finds this file, spring.factories, in the meta inf directory of various jars. Your jars, our jars, anybody's jars, right? It doesn't matter whose spring.factories. It'll evaluate all of them basically. So the one that matters to us, however, is the one in Spring Boot auto configure, and there you'll find a long list of configuration classes. So if you look at this, it says Rabbit auto configuration. This is a Java configuration class. It's a Spring Framework configuration class that defines beans, right? So you saw back here in my code, I created beans by registering them with a stereotype annotation, right? Like add controller is in turn annotated with add component. That's one way of telling Spring about the presence of your objects. That is to say, the objects that it needs to wire up for you. And the way you do that is by annotating it with add component. Anything with add component or meta annotated with add component, like add controller, is by extension a bean that gets registered in the context. You've also got the ability to register beans thusly. So you say return events, let's say hello world, right? So here I'm registering a bean explicitly with a handler provider method, right? Or bean provider method. So this method is going to be invoked when the application starts up, and then it'll return a bean of type application runner, and the context for that runner is an events, and it's going to print out hello world, and all that good stuff. So that's a bean as well. The ID of the bean is runner, the type is application runner, and so on. So this is how Spring sees the different relationships in your API. Okay, so it goes through and it looks for these. Let's close some of these here. It goes through and it looks for these different auto configuration files like Rabbit and Batch and whatever, and it says, okay, I'm going to evaluate all the configuration. Right, it's a configuration annotation. This annotation
Spring Boot application is itself meta-annotated with add configuration. So add configuration is right there. So this is, by extension, add configuration. In fact, this is redundant. It doesn't hurt to add that. It's meaningless. It doesn't do anything different. But the point is that's what that's doing, right? So any configuration class can have bean methods. And so we've got these different auto configuration classes. This is a configuration class that provides beans related to RabbitMQ, like a caching connection factory, like a RabbitMQ connection factory, all this kind of stuff. Well, of course, you can see my IDE is signaling that these types are red. That means that they're not on the class path. They're not there, and therefore there's no point in trying to instantiate an instance of this type because it would most assuredly fail. So the configuration class, it has conditions. And these conditions are like this one, conditional on class. It says, if this type is not in the class path, then don't bother trying to instantiate all the objects, all the beans, and the nested configuration classes therein. If those conditions are true, however, then it'll continue on until it gets to this condition. This one says, hey, has somebody already registered a bean of type connection factory? If they have, then don't bother, instantiating this connection factory because it's already been done. We can just use that one. Any object, any configuration in the Spring application that needs a bean of type caching connection factory can just inject it because it's already been provided by somebody else. But if it has not been provided, then we need to provide it right here. And the reason we want to do this is to give you defaults. So this is the magic of Spring Boot, is that we give you sensible defaults at every stage. And that's why you didn't see me instantiating a data source or a web server or even a persistence framework or anything, really. You didn't see me configuring the web tier framework, the Spring Web Flex. You didn't see any of that. And the reason you don't see that is because it's just done for us by default based on these queues that get evaluated at startup time. Things like what beans are present and what classes are on the class path. Now, you might want to override some of these defaults. You might say, hey, this is a caching connection factory, and I like what it's doing, but I want to change one little thing. Okay, well, then feel free to define a bean of type connection factory or caching connection factory, and that'll get used. Okay, that's just fine. One thing you don't need to override a bean definition for usually is the configuration of that bean. So what host and port, what credentials, what username and password should it be using? That stuff is very stringy, stringy kind of configuration. That kind of stuff can live in a property file, right? So you might have RabbitMQ, port is whatever, blah, right? Who knows? And if you specify this property value, spring.rabbitmq.port, you can see if I command click on this, and in my IntelliJ Ultimate version, it's not available in the Community Edition, but it is available, by the way, in Visual Studio Code and in Eclipse and all that. If you see, I command click on that, I can see there's a setter here called setPort. SetPort, in turn, is a method on this object called Rabbit Properties. And Rabbit Properties is annotated with @configuration properties, which says that all properties that start with spring.rabbitmq are going to be mapped to this Java object instance, and those will be made injectable. And that's what's happening here, is we're injecting a Rabbit Properties object in this connection factory. So we inject the Rabbit Properties, and then there's all this work being done here to basically read things like determine the host addresses using the properties, get the addresses, shuffle mode, get the publisher returns, and then set it on this factory bean, right? So we're taking the properties, copying the strings from the configuration properties object to the factory bean for this RabbitMQ caching connection factory. But basically, that means that all you need to do is to impact this Rabbit properties, and you do that, as I said, by setting these values in your config file, external, internal, in a config server, etc. We'll talk more about that in a bit, but suffice it to say, this is another way you can override the default behavior in a Spring Boot application. Okay, well, we've got our basic Spring Boot application. We've looked at reactive programming, we've looked at R2DBC, and we've looked at Spring Web Flex to build very trivial web services, very trivial HTTP endpoints here. Hopefully, you can see the possibilities there.
We said we wanted to get into production, right? Well, that means that we need to package our application just so, as a container, as a Docker container in particular. Docker, of course, is the name of the company that created the Docker file format, and that was inspired by the term dockers, people who work on the docks. People who work on the docks often deal with shipping containers. Are you seeing what is happening here? According to Wikipedia, shipping containers were first invented in the early 20th century. Modern 40-foot intermodal containers proliferated during the 1960s and 1970s under the containerization innovations of the American shipping company Sealand. Interestingly, here in the United States, the major ports are almost always adjacent to major cities. So, while I live in San Francisco, the biggest port here is in Oakland, just across the bay. I can literally see it from the top of my building. The port of Los Angeles is in Long Beach. The port of New York is in New Jersey, and so on. So for better or for worse, the ability to have shipments arrive at any port cheaply and efficiently is one of the major contributors to the increasing globalization of our economies. It helped make it cheaper for organizations to manufacture components in one country and then ship them across the planet in containers for assembly in some other part of the planet, right? As opposed to doing all that in place. On the one hand, it meant that businesses could leverage goods and services in other economies, making it easier to distribute wealth around the planet. This, inarguably, can be a good thing. It helped lift a lot of people out of, poverty, really. I mean, it did some amazing things. On the other hand, it sometimes leaves those whose jobs and livelihoods were offshored to some distant land feeling angry, right? Resentful that their life can be so easily wasted, especially if they have no other skills on which to fall back. That's a real shame, right? Because obviously that's not the intended goal here. So, good, bad, there's a whole debate there. Just like shipping containers, like real shipping containers, Docker files can also leave you angry that a person's life can be so easily wasted. I can't think of a thing more tedious than writing Docker files. I mean, and that's not true. I can think of a million things more tedious than writing Docker files. But if you're lucky enough to have a Docker file as one of your problems, it's a problem you don't need to have, right? And so in this section, we're going to look at ways to get apps into containers so that you can get containers into production where your users can use and enjoy your efforts. Let's dive right in. All right, we've got our application. It's all here. I want to now deploy this to production. And so this, as often as not, means getting containerized. So we'll start with the most obvious step, the most unfortunate step. We're going to create a Docker file manually. Okay, so Emacs Docker file, and then we're going to say from adopt open JDK. Oh my God, I'm going to fall asleep. This is so not fun. This is not why we're here, people. This is a waste of time. So hotspot arg jar underscore file equals target snapshot.jar, copy jar file to application.jar, the root of the context of the container that's being built. We want to expose port 8080 from the application that's going to be running. We want to specify the entry point as being Java minus jar application.jar, right? So application.jar. Okay, we need to build it, so we'll say emacs build.sh user bin env bash, and then the build is pretty simple, right? So maven skip tests clean package. Then we will say docker build minus t image name space. Now, image name, what is image name? Well, image name is a combination of a prefix and the actual, app name, okay? So what is the prefix? Well, the prefix, I say, let's do CNJ, okay? Cloud Native Java. And then app name is equal to whatever, packaging, who cares, right? And then we want to run it, right? So docker run image name, right? That'll do the job, but on what port do we want to run it? Well, I can set an environment variable. By default, it's 8080. It won't be published though until we expose it. But I can also set an environment variable to override the port. So let's say I wanted to do server port equals 8082 as an environment variable -e, and then I want to say publish port 8082 internally to 8082 externally. Okay. We want to run that. So we'll say build and then run. Oh, something's wrong. Did I fail to do the right thing there? So let's see. Subble Emacs
build.sh. Okay, that looks okay. Emacs, Docker file, copy the jar file. Jar file is equal to target asterisk snapshot. Oh, hi. It's not Windows. Case matters. Okay, build one more time. Good. So there's our application inside of a container. Everything seems fine, right? Hello world. Good stuff. Now, can we do better? Well, of course, there's things we can do. One thing that we might do is to use a plugin like the Google Jib plugin, which I quite like. It's really fast. So we can go down to our plugins here and just add the support ourselves. So plugin, and then the plugin will be group id com.google.cloud.tools. Okay, group id, artifact id is Jib Maven plugin. The version is 3.1.4, and the configuration is, this is where things get interesting, right? So we want to configure it to be image CNJ packaging, right? Or let's do, well, yeah, why not? Packaging, who cares? It's fine, right? So image to, and then that's it, right? That's the entirety of the configuration. We need to modify the build script here. And the build script this time will, instead of manually building everything, will run the Maven plugin, right? So the plugin here is clean package jib :docker build, okay? Emacs pom.xml. Oh, okay. Alrighty, there's our application, not bad. And that works okay too for Java, right? I like that approach. It works just fine. Now, that said, can it get easier? Could we do even less to get ourselves an image? And what about for other languages as well? Well, this is where build packs come in, right? So there's this idea of build packs. It's a specification, part of the Cloud Native Computing Foundation. It itself was the result of a collaboration of the work between Heroku, who inspired the concept way back in, I don't know, 2008, whatever. I mean, it's a long time. And then the Pivotal team working on Cloud Foundry, the same team I was on. I worked at Pivotal for years as part of the Spring team. We're all now part of VMware, part of Tanzu. But that same team working on Cloud Foundry embraced the build packs idea. And so there's interoperability there for a little while, but they aren't the same effort. They're the same, usage, but there's different efforts. And then eventually we converged, and that became the Cloud Native Build Packs here at the CNCF, right? And there's an implementation of that, supporting concepts, supporting different builders. A builder is a thing that, given an artifact, like a source code repository for Ruby and Rails app, or a Java application, .jar, .war, whatever, given that, it turns it into a container. And you can download a CLI called pack, and you can do a build on any given artifact. You point it at a Python Flask application or a Vue.js static client-side application and whatever. It'll give you a container that's required to run that. So in the Vue.js case, it'll give you an Nginx to run and host your static web assets. In the case of your Spring application, it'll download a JRE and set up all the Java agents that you specify, if you do specify any, and it'll run that and so on. So I like this. I like this a lot. Let's we can use this, but it's already built in out of the box with Spring Boot. You don't need to add anything to the build. So what we're going to do here is just going to go down and remove gib. There's just no point to it, right? It doesn't add anything. So there we are. Save. And we need to modify the build. And what we're doing here that's different is image name equals image name. Okay, I forgot to do one thing. I forgot to actually invoke the plugin. So let's go back here, Emacs build.sh. And then here we're going to say Spring Boot build -image. There we go. That's the important bit. Let's try that again. So you can see it's downloading the Paketo builders for us now that I've invoked the plugin. And it's just like gib. It'll create a container and it'll publish that container into our local registry, and we can then Docker tag and Docker push it and so on. Goody, there's our application. It's been published. It works as we expected. And so there you go. It's pretty easy, right? Now you have an application that we've gone from a Docker file and a build script to just a build script and some Maven, and then we went to just a build script, basically. There's no extra configuration required at all. We can delete the Docker file, we can delete the gib plugin, and we get something that also, because it's based on this concept of build packs, which are surfaced as part of the pack CLI, you can use it with any runtime. And the nice thing about build packs is that you can override the base images that are being used. So if you have a security update or whatever, you can just, you just put that new base image out there and everything can pull from that if you like. All right. I hope you got something out of that. I think this is there's a lot of potential here. One interesting opportunity that we're going to explore in the next section is turning this image, this Java application, into a GraalVM native image.
Getting our Java applications into a container is a huge part of the work of getting to production, but we're not done. We can still improve things. One opportunity is GraalVM. GraalVM was originally created as a replacement for the tangle of C++ and Java spaghetti code that is the current hotspot just-in-time compiler, or JIT. JITs take frequently accessed code paths and turn them into native code. What I mean by native code is machine architecture specific code that runs really quickly and with little memory on a given architecture. The JIT is the unsung hero of Java's vaunted speed and scalability. Thanks to the JIT and the garbage collector, some Java applications can run faster than similar C or C++ applications because they have visibility into the global memory pool of the application as opposed to localized memory usage. And this is amazing, right? Large organizations use Java for precisely this kind of efficiencies. The JIT is awesome, but it only works for frequently accessed code paths. So some organizations, like Google, take advantage of this fact by warming their services up to get them ready to go into production. They exercise frequently accessed code paths or important code paths enough times so as to invoke the JIT compilation before they throw traffic at them. The obvious question, of course, is if the just-in-time compiler and the resulting native code is so amazing, why not just-in-time compile the whole thing, ahead of time, which is exactly what an AOT or ahead-of-time compiler does. GraalVM also has an AOT compiler that supports ahead-of-time compilation. The AOT compiler statically analyzes the code at compile time and throws away everything it perceives will not be used at runtime. Everything from your code, from your dependencies, and from the JRE. The trouble is that Java is a funny old language. It may seem to have more in common with its stodgy cousin C and C++, but in truth it has a lot more in common with languages like Ruby, Python, JavaScript, and Smalltalk. It's got the concept of a runtime, where you can influence the environment in which the application is running at the same time as it's running. It's possible to take the source code for a Java class in a Java string, compile that string into a .class file, register that class file with a class loader, then reflectively instantiate an instance of that class, or create a JDK proxy out of an instance of that type. Assuming, of course, it's in It's an interface. Then you can serialize an instance of that type to disk, and then you can read it back into memory, all without ever having referenced a actual type. You can do it all in terms of reflection APIs, strings, and Java lang object references. It's not quite as easy as eval, like the eval function in various other languages, but it's pretty darn close. And that's one of the reasons why Java is so amazing. That's also the rub, right? GraalVM can't see about all this dynamic behavior that's intrinsic in most Java applications in its static analysis, unless we tell it about it, right? We need to actually provide hints in the form of various JSON configuration files that the GraalVM native image compiler will pick up when it compiles your application. So here's where Spring Native comes in. Spring Native, and along with the Spring Aot Maven plugin, act as a sort of clearinghouse for transformations that happen at compile time, and the results of which get fed into the GraalVM native image compiler. It's awesome because it provides all the hints that you will need to make a Spring application work. So obviously, there's a lot of potential here, because imagine you could take all the applications that you've built and get them to work as native images that take markedly less RAM and start up in fractions of the time that they started up before. The potential is endless. What we're going to look at is Spring Native, which is currently an external experimental project. It's not yet GA. But the goal here, the ultimate goal, is to get all of this in Spring Framework 6.0, coming out later in 2022, and Spring Boot 3.0. So the hope here is that this will be a first-class citizen, but it's really good already, and I want you to see it, and I want you to be able to kick the proverbial tires. So let's dive right into it. One possibility that's really interesting is taking your application and converting it into a native image using GraalVM. Now, GraalVM is an ahead-of-time compiler. It was built with a core conceit that if using a just-in-time compiler to turn parts of your code is interesting, then surely having a faster JIT would be very interesting as well. And so they built a new just-in-time compiler. It is built in Java, or it's like mostly Java, as opposed to the tangle of C++ and Java code that's in the original just-in-time compiler. And it runs really quickly. It's super fast, right? And in of itself, it's interesting, right? You could use that in production and still get some huge gains in your efficiency. But the real interesting opportunity comes into my mind, in the native image builder, right? There's a tool, an extra tool that you have to install, by the way, by doing gu install native image. And that's a tool that's already installed on my local machine. But once you've downloaded GraalVM, which is after all just basically an OpenJDK distribution, once you've done that, run gu install native image, then you'll have the GraalVM compiler on the class path. And then you can compile your applications using this new ahead-of-time compiler, right? This ahead-of-time compiler does static analysis on your code, and it has as its goal to figure out where your application is doing anything, or rather where it's not doing certain things. So that is to say, if you've got a class path full of a bunch of code that it's not using, it wants to throw all that away. And it determines that by looking statically at compile time for anything that's being referenced, basically, any reachable sort of types. And if it can determine at compile time that something is being used, it chucks it out the window with so many of our hopes and dreams. And this sounds like a good idea, except, well, Java really needs that kind of stuff, right? It's Java is a very dynamic language. It's a funny old language, right? While it feels at times maddeningly stodgy and old and slow and weird, and seems to hearken more to the days of C and C++ than the days of Lua and Ruby and Pascal and not Pascal, Erlang and JavaScript and Python and whatever. It's actually got a lot more to do with those newer languages, those more dynamic, scripty kind of languages, right? You can do some very amazing things with Java if you really wanted to. You could write the code for a class in a Java string at runtime, and then take that Java string and turn it into to bytecode that gets loaded into the class loader as a class dynamically at runtime after the application started. Then you could, using reflection, instantiate an instance of that class. Or if you wanted to, you could actually create an invocation handler-based proxy of that class, if it's an interface. And then you could reflectively invoke methods
on that class, on that instance rather, of that class, all the while never having a reference to an actual type. If you wanted to, you could also then serialize that class, right? Again, never actually dealing with an actual type. It's all done through a reflection. So this isn't quite as powerful as eval in different scripting languages, but it's conceptually the same thing. You can do the same things, which is crazy if you think about it, right? And because of that, Java is really dynamic. It has a very dynamic runtime and can do a lot of amazing things that you just don't really think about because we're just sort of used to it being awesome, you know? So this is where some of the trouble comes, is that GraalVM doesn't know or care about any of that cool stuff, but Spring does. Spring uses a lot of that cool stuff. So what we need to do is to make GraalVM aware of those particular things. GraalVM doesn't, it's not like an ostrich. It's not sticking its head in the sand saying, I don't care about any of this. I don't see it. It's not possible. It just doesn't know about it. And so we have to tell it about it. And the way you do this is with configuration. And so this is where the Spring Native project comes in. Spring Native is a set of, it's a compile time tool that we built that provides hints. These are called hints in the Spring Native world, but they're basically the types that contribute ultimately to the configuration files that get fed into the GraalVM compiler. These hints tell GraalVM about all the places we're doing reflection, serialization, loading things from a class path, like a jar image or whatever, or you have an icon file or whatever, or properties file. It tells it about all the times we're doing in proxies, both JDK and Spring Aot proxies. It tells GraalVM about all this stuff, right? And so the result is that hopefully, if we've done our job right, you'll be able to bring your application unchanged and get it to work as a native image. Now, this is a huge and very ambitious goal, right? Because it's, well, I mean, think about all the different use cases that Spring supports, right? Over almost 2 decades, right? There's a lot of support there, a lot of different things you can do with it. So what we're going to do here is we're going to take our build and we're going to add Spring Native support. And mind you, this is not yet GA. It's experimental on the Spring initializer. So we'll do that. Reactive Web, R2DBC, H2, Lombok. And what do we call this? We called this customers, right? So call that customers. And we'll hit explore and just get an updated copy of the configuration. Paste that in there. Reload project. And that greatly lengthened our build file, right? It went from, 169 right now. So what was it before? It went 76. It went from 76 to 169, and that's mostly to do with configuring the Maven plugin for GraalVM and configuring the JNet support there. And configuring a profile, a Maven profile called Native that you can use to package in Maven a GraalVM image. It adds the experimental and milestone repositories. It adds the Aot Maven plugin. That's a Spring Aot Maven plugin that acts as a clearinghouse for transformations that need to happen to the code before they get fed into the GraalVM compiler. It modifies the build pack support that we talked about. It'll now generate a tiny image, that is to say, a much more minimal container. And the reason is because we don't need everything before. The JRE is not present anymore. The resulting GraalVM image is going to be native code. It's an architecture-specific binary that takes tens of megabytes of RAM and starts up in almost nothing. So, it adds a lot, but it's done for us. So I suppose that's something. Let's go ahead and test it out. We'll go ahead and hit Maven -p native. Skip test, clean package. Okay, now this will take a while, so we'll kick it off and I'll talk to you after the break. All right, that finished. That took so long because it's not doing static analysis only on your Java source code, but also on the application's libraries as well, all the .class files in the jar on the class path. This can be quite substantial, as you can imagine, and it's also doing analysis on the JRE. So it's deciding what things you're using from all the class path entries and from all the code in the SDK, and throwing away everything that it decides you're not using. And of course, that's a lot of work, so it takes a long time. But our application's been compiled. We can go to the target directory, and we've got a binary there. Whoops. I don't know why that one the first one on Mac, for some reason, very slow. But there you go. That's more typical, right? And you can run it here, localhost, customers, and everything is as you expect it to be. Great. Okay, so we have a Spring Boot application that's using the generated code from the Aot plugin. You can see that reflected here. And it's fast, right? This is one way to get your application. The problem, of course, here is that this is a native binary. So it's 85 megs, and that's it. You don't have to have a JRE, you don't have to have a JDK, you don't have to have anything. You can just run that. But you do need an operating system, and in this case, you need Mac, you need OS X, right? You need Mac OS, you need whatever your operating system that you compiled on is. You need Windows or Linux. And if I want to deploy this into a Linux container, well, it's not going to work. And so one good option is to use build packs. All right, let's use build packs to compile the image inside of a Linux container. So Maven skip test, because it'll run the tests in the context of a native image. Clean package spring boot : build image. Go. All right, so completed running. We can now use it, right? So successfully built this, Docker run. There we go. There's our application up in 0.082 seconds. 82 out of 1,000 milliseconds per second, right? Blazingly fast inside of a Docker image. All we got to do now is Docker tag and Docker push that, and we can deploy it to our Kubernetes cluster. This is a Spring native application in that it's got Spring native support there. But it's not perfect, right? The goal ultimately is to get this stuff into Spring Framework 6.0 due next year, and Spring Boot 3.0 also due next year. There, it'll be integrated into the whole of the ecosystem. Right now, we're using it as both a solution, but also as a research bit, right? We're pretty sure we understand what it's going to look like. What making GraalVM a native part of the Spring ecosystem looks like. But things could change, right? There might be a little bit of volatility here and there. Hopefully you will be pretty well insulated by from it by this point. It's been a while since we introduced Spring Native. We've been working on it for well over a couple of years, and the result should be good enough for a lot of use cases or a lot of applications. But there are some cases where you might find that things don't work as you expect, and if that happens, you can use these hints, right? And let's say you have a type that Spring doesn't know about that is doing reflection. Well, you can do a type hint. Okay, you can say, I want to reflect on whatever. Let's say, in this case, it wouldn't be a problem, but let's say that for some reason that Spring didn't know about customer, and of course it does because it knows about the repository. But if it didn't know about customer, then you would say, okay, I want to do a type hint for a customer, and the what kind of access do I want? Well, I can say access bits dot all, right? What if I want to do serialization? Well, I can do serialization hint, right? If I plan on doing serialization somewhere, I specify that here. If I wanted to do, let's say, JDK proxies, right? Well, then I might want to do that. Or if I want to use Spring's cglib-based proxies, I could use an AOT hint, right? And then, of course, you'd specify, you'd specify the target class and then the interface, right? So interfaces equals, let's say, I don't know, some other whatever other interfaces you have to care about, right? So if you have transaction aware, I don't know, right? Transaction aware. I just need an interface, just anything, right? Interface foo, right? Foo.class, okay? Those are optional, okay? So you've got these hints that are built in. There's others as well besides, and you can kind of use the umbrella one here called native hint to kind of figure out what options you've got. I haven't looked at initialization or resource hints. If you have a resource, you might care about this resource hint. This is for, let's say I have a file called data.csv that's in some other class path besides our own. That is to say, everything in source main resources in this jar or in this binary is already taken care of. Don't worry about that. But if you have a data.csv in a library class path, in the jar on some other library, then you might want to load that into memory as a class path URL. And if that happens, then you need to specify that. And a very common case for this is if you're doing resource bundles, and then in which case you'd say, is it a bundle is true, right? Now, as I was saying, this native hint is kind of an umbrella. You can specify everything that I just specified here as part of a native hint. And the reason you might want to do that is, first of all, because you can aggregate, you can have more than one of those hints, but also because you can actually qualify when to activate a native hint. So trigger equals, and here I can say, okay, I want this to run if and only if this foo is in place, or if rabbit auto configuration evaluates to true. Remember what we talked about earlier about how there's these conditional on classes? Well, these conditions get evaluated when the application starts up, but there's no need for that at this point, right? There's no link path anymore in the native image world. There's no possible way that a class that was there at compile time won't be there at runtime, and vice versa. There's no way that a class that wasn't there at compile time will end up being there at runtime now. They're the same thing. By the time it's compiled, we know exactly what's going to be in the native heap's memory, and so we can evaluate this stuff at compile time for you, and that's what we do. And we have a trigger here that says, okay, for certain conditions on different configuration classes, if they're true, then and only then activate the rest of this, right? So we can say, I want these hints to work or to be put in place if and only if there's an auto configuration class on the class path, right? That's very powerful. What else do we have here? We have options. There's lots of different options you can put here, like enable, URL protocols or something like that. There's lots of stuff that you might want to pass in to a GraalVM compilation that you can specify as options. You can do, like I say, there's JDK proxies. So I can put this here. I can do AOT proxies and put that there, and serialization. Put that here, and voila, right? So these are all hints that could be specified, and will activate only if rabbit auto configuration activates, right? Okay, now this is pretty good. You can actually put this in a class on the class path, and my class, my native hints implements native hint, right? And this job, it's not native hint, it's a native configuration.
We've used HTTP thus far, and that's fine, I guess, but I'd like to encourage you to take a look at RSocket. RSocket is a protocol that was designed by Facebook that makes real or reifies the concept of reactive programming on the wire. It has built-in support for back pressure, which is the ability of a consumer to push back on potentially overwhelming demand, and it has support for leasing and many different message exchange patterns and bidirectional communication, and it's stateful. The idea that once a service connects to another, they stay connected for the life of the application. It's a very powerful protocol, so I can't wait to show it to you and see how easy it makes to build efficient, scalable services. Let's get right into it. Service, our customer's endpoint is using HTTP, and that's fine, I guess, but I'd like to encourage you to use RSocket. RSocket was created by engineers at Facebook who were originally from Netflix, and it seeks to provide a solution that gets around some of the limitations of things like HTTP, HTTP 1.x, HTTP 2.x, gRPC, etc. It is a binary protocol. It makes real the concepts of reactive programming. So it actually has in the protocol message frames the ability to communicate things like back pressure, which is a concept you only see when you talk about reactive programming in particular. This is one of the reasons it's so powerful, is because it's robust. You can build services that have the ability to transitively communicate back pressure from one service to another, all the way down the line. It could be across many different hops, and that would still work. It supports multiple different kinds of message exchange patterns, like request response, fire and forget, bidirectional streaming communication, and single direction streaming communication, where you send one value and you get multiple values or potential unbounded values back. So let's create a new order service, and this is going to be a service using the RSocket support. We'll use Java 17 because we can. We'll hit generate, and we'll open this up in our IDE. Now the orders microservice is going to manage order data associated with each customer. The idea is that the microservice, the application that we built earlier,
will manage the customer data. But order data, you might argue it should be part of the same aggregate, the same bounded context, because the data of the orders shouldn't exceed the life cycle of the customers. And that's fair, but in practice it's not true, right? Like if you're doing revenue recognition, you keep orders around, even if you tombstone or delete the customer data. So the life cycle of the order, a lot of times will exceed the meaningful life of the record for the customer, okay? So I'm gonna run this on port 8181. And we're going to create a controller here. And the controller is going to be a order RSocket controller. Okay. And we're going to create a record using Java 17 records. And so it'll have two fields: the customer ID, which is the thing to which this in theory belongs, and the ID of the order itself. Okay. And of course, we'll just introduce that. This RSocket endpoint, we want to have it give all the orders data given a customer ID. So we'll get orders for, and then we're going to provide a variable. It's not a path variable like in HTTP, but it's a destination variable in the RSocket world. All right. And so we're just going to synthesize this, right? Like for now, I'll just have some dummy data that we can use so that when somebody comes and requests the data, we'll just give them back some simulated data, right? So map of integer collection of order db equals new concurrent hash map, and we'll say for var customer ID equals 1, customer ID is less than, 8, because we have 8 customers, right? So, and we'll say var orders new array list of order. And we're going to just simulate some data. So for var order ID equals 1, order ID is less than or equal to math.random times 100. And order ID. Okay, orders.add new order, customer ID, and then ID. Voila. Okay, there's this. And this.db.get customer ID will give us back a list of orders. And then we'll turn that into a reactive stream. Right, so voila. There we go. So now let's try this out. Let's go ahead and start it up. Oops, I don't think we've got to do the most important bit here to actually set the data in the database. So given the customer ID, we'll have the orders. And now we'll restart. Okay, it's up and running. Good, let's try it out. So, whereas you might use curl for HTTP or HTTPI, I like to use RSC for RSocket. So you say TCP localhost 8181. The route is called orders dot and then some destination variable for the customer ID. In this case, let's say 2. And the type of interaction, the message exchange pattern that we're using is streaming, because we're sending a single value in, or no values in this case, and getting 0 to n values back, where n is in this case potentially unbounded. So let's hit enter, and we get a response back. Very cool. Now RSocket is very powerful, right? We've only begun to scratch the surface here, but there's support in Spring Security, there's support in Spring integration, there's support in Spring Cloud. RSocket is also the first protocol that we donated to the our work along with Facebook and Netflix and others. That's the first thing that that was donated to the Reactive Foundation, right? The fledgling Reactive Foundation. And there we're developing a broker along with our friends over at Lightbend and Alibaba and others. We're developing a broker that will act as a sort of hub, a gateway. So imagine you've got a bunch of microservices that are deployed, and you've got an edge service that acts as the gateway between you and the outside world. And requests come into the edge
The edge service is a hub, if you will, and it's an RSocket broker, so it knows how to accept incoming requests. Remember, in RSocket, requests are stateful, so once one side connects to the other, they can stay connected for the life of each application, for the process. You don't reconnect each time. This saves significant amount of time because you're not constantly doing network connections and ACK and handshake and all that stuff. And so the hub accepts incoming requests, or better yet, it reaches out to each of the RSocket services. The RSocket services, it can go either way, but if you wanted to be secure, the RSocket services would reach out to the hub. The hub would stash a reference to that socket, to that connection. And whenever a request comes in, it can say, okay, which one of you available sockets is busy? And there's information that you can, it's through leasing. There's a concept called leasing. There's information enough in the protocol itself for us to be able to ask that question. And we can use that information to decide to which service a request should be routed. Now think about this. We have the Spring Boot actuator. The Spring Boot actuator gives us information about the state of a service, the health of a service. But wouldn't it be nice if that was just part of the protocol, like part of the protocol itself? Well, with RSocket, it is. You don't have to have a convention to get this. It just works. So we can now ask questions like, how busy are you? This is kind of like a reverse back pressure, where back pressure allows the consumer to control the rate at which it consumes data. This leasing mechanism allows the producer to tell the client or the consumer whether it can handle the request in the first place. And so this is very good because you get smart load balancing opportunities here. The client can in production, nobody can hear your application scream. Or maybe that was space. I don't know. But either way, we want our application to be able to articulate its own state. We need to know if everything's okay. Poor little fella, it might be unwell. We need to do something. And observability is how we do that. It's the art of instrumenting the application to support that and sometimes even things like automatic remediation, where certain classes of errors can be automatically repaired without human intervention. This is all certainly within the realm of possibilities with a dynamic platform like Kubernetes. Obviously, you can do a lot of things with this information. You can surface it in a dashboard, and you can even connect it to a Raspberry Pi. My friend Phil Webb, and he's also the co-founder of Spring Boot, he and I built a demo back in 2014 where we built an application that monitored, on the Raspberry Pi, it monitored Spring Boot applications via their observability support, via the Spring Boot actuator. And whenever it perceived that something was wrong with the application because the actuator indicated as much, the Raspberry Pi would either play a sound file on the using a connected speaker saying danger, danger, which I thought was great, or in a separate demo, we connected it to a coffee machine because we just knew the implication was if there's something wrong, somebody's going to be up late and they're going to need a cup of coffee. Either way, I like the potential. I like the idea that we can do things to respond to the state of the service, the meta state of the service. And this is also very important, is that this is information about information, right? It's metadata about the application proper. And there's a lot of possibilities for load balancing, for operations, for scale, for all that that become within reach if you have that ability. So let's dive right into it. We've looked at how to get our application in a working state. We've looked at reactive programming and a few other things here and there. I think we're ready to go, or at least start moving to production. That said, it's not clear what's going to happen once we get there, is it? Because our application hopefully will work, but we have no way of knowing, right? We have no way of asking it how it's doing. In order to support that, we need to support observability, right? Because remember, in production, nobody can hear your application scream. So what I'm going to do is I'm going to go back to my build and bring in the Spring Boot Starter Actuator. And the actuator is a managed set of endpoints. It gets automatically created for you in your application. Let's go ahead and restart. And we'll go to the browser here, localhost 8080/actuator. And we can see that there's very little available. That's because by default, this is all locked down. We'll go to the property file and we'll say we want to expose everything. We want the health endpoint to always be there. And I think that's enough. Let's go ahead and restart. Okay, so now if I refresh, you can see there's information about all these different endpoints. And by the way, I've got a pretty printing browser plugin. If you look at the source code, it's just regular JSON, but I've got this little plugin that allows me to collapse and expand little different stanzas of the JSON. All right, so this is a hypermedia enumeration of all the different endpoints. I've got the mappings endpoint, which shows me all the different HTTP endpoints in the Spring application. So for example, I have an application endpoint called actuator beans that produces application JSON and any of these three different content types, and it responds to the /actuator/beans endpoint. The component that actually provides it is here. It's a read operation handler, and the handler method in particular is called handle, and there are certain methods that are supported, and it produces certain content types and so on, right? So you can kind of get a feel for all the different HTTP endpoints, and you can use this for auditing, right? Very useful. We've got the scheduled tasks. We have no scheduled tasks right now, but if you're using the Spring Framework trigger, which underpins things like the cron support and add scheduled and so on, then that'll all show up here. So you can see any scheduled tasks here. There's actually a scheduled task executor, that kind of thing. We've got metrics. Now metrics are super useful. This is good for high cardinality data where you want the aggregation of the data. So not the individual request for Josh or whatever that goes through the system, but instead information about all the requests. So for example, how many HTTP server requests have there been? Okay, so I can do that. I can say, give me that. HTTP server requests, there's been 4 requests so far to the service. The statistic of the total time taken is this long. The max time is this one. Was there any exceptions? No, so far, but I mean, it could be, right? What verbs were used? I can break it down by, show me all those that had a method equals post and not get, right? For example, and what URLs were hit and what was the outcome. I can just, these are all called tags in the actuator endpoint. But another way to think of it is a dimension of the data, right? So this abstraction, this metrics endpoint is supported by something called Micrometer. Micrometer is a vendor-neutral applications metrics facade. As the webpage says, think SLF4J, but for metrics, and it supports integration with any number of different time series databases in the back end, including AppOptics, Azure Monitor, Netflix Atlas, CloudWatch, Datadog, Dynatrace, Elastic, Ganglia, Graphite, Humio, InfluxDB, and Telegraph, JMX, KairosDB, New Relic, Prometheus, SignalFX, Google Cloud, Stackdriver Trace, StatsD, and of course, VMware's Wavefront. I hope to get to in just a bit. So these are different time series databases. Prometheus is very common in the Kubernetes space. It's a very, very popular choice. Graphite is the, 800-pound gorilla, right? We've all probably used Graphite at some point. And if for whatever reason, the time series database that you want to use isn't in that list, then there's always the StatsD support, which is a protocol for communicating metrics over the wire. And it's a very simple protocol, but if you don't see a particular integration there, then there's probably a chance that whatever you're using to ingest metrics will support the StatsD protocol. So lots of good support here. This is a spiritual successor to our original support for drop wizard metrics in Spring Boot 1.x, right, from years ago. This is very, very powerful. And besides having more integrations, the thing that's interesting about it is that it has this idea of hierarchical metrics, right? Different dimensions of metrics. So I can ask for a core metric and I can ask for different dimensions of that metric without having to have a separate metric. I don't have to have another metric called http-server.request.seconds and another one called http-server.request.exception. And then if I want one that does both, I don't have to do http-server.request.seconds and exception, It gets very unwieldy very quick if you do that. But with hierarchical metrics, dimensional metrics, multi-dimensional metrics like this, I get to pivot. I can ask for data in terms of a particular dimension of the data. Very, very powerful. We've got the Heap Dump endpoint, which of course gives me the heap. Loggers is an endpoint that gives you all the log levels and all that. You can actually post to this endpoint and change the log level for a particular log. And so if you want to debug something coming out of org spring framework.web or whatever at runtime, you can do that without having to restart and change the config. We've also got the health endpoint, which gives us information about the health of the service. We're going to come back to that. We've got the env endpoint, which gives us all the different things that are considered part of the Spring environment. And we'll look more at the environment and configuration shortly. But for now, what you need to know is that this is an enumeration of all the different system properties and environment variables and all that kind of stuff that you have in your application. Now, you might keep, for example, a password in your environment variables. That's very common, right? If you want to test your application, but you don't want to check in source code containing that password. Well, you could put it in an environment variable, but we automatically mask out important things like the command and underscore password and underscore key and token and secret, all that kind of stuff automatically gets masked out. So any property that contains something that could spill or leak your passwords, we try to mask that out, and it's configurable. So if we missed, for whatever reason, a key, then you can specify that as well. So this is very useful. It's also great for determining what, if any, the delta is between your production environment and your CI environment or your local platform or whatever, right? If you want to figure out why something isn't working there, but it is here, it might come down to a missing environment variable or a misconfigured environment variable or property or whatever. So this is very convenient. We've got the conditions. We got the config props endpoint, which enumerates all the different properties to which the current application will respond. So we looked at the configuration properties endpoint before, we looked at the configuration properties annotation before, and we saw that can be used to tell Spring Boot that a given object is used as a mapping of properties of strings that can be plugged into configuration, right? Well, if you want to see what properties are out there, since the object system knows about them now, you can check all this stuff out. So, management.endpoint.health.showDetails equals always, right? You saw that I specified that already. I went to my property file here, and I said management endpoint health show details equals always. If I had changed that to be when authorized, refresh, and it says when authorized now, right? So this is very, very powerful. I'll restore it to always. Okay, so lots of different properties here, lots of different configuration options there that you might not even be aware of unless you go to that endpoint. By the way, this index of properties is based on a configuration processor that you can get on the Spring Initializer. So if you go here and you want to add support for enumerating your own custom configuration properties objects, add this to the class path. It'll result in an index that gets contributed, and that index gets used by all the tools, right? All the tools that support this will use that same index. So you get the same auto completion, the same suggestions, whether you're using NetBeans or Visual Studio Code or Spring Tool Suite or IntelliJ Ultimate Edition. Okay, so we've got the conditions endpoint, which tells you all the different conditions that were evaluated before the application started up and what the results were. So you can determine how the application congealed into the final form that you see before you. We've also got the caches endpoint, which shows you all the different cache manager implementations. The beans endpoint, which tells you all the different objects in the Spring application, including those contributed through auto configuration and through your own custom code, where those beans were defined, their types, their scope, that is to say whether there's a single instance per application or if there's 1,000 or if it's request scoped or thread scoped or session scoped or whatever, and any dependencies. So this bean of type caching operation invoker advisor must have a dependency, it seems, on something called an endpoint auto configuration, and so on, right? And so this is great if you want to see the wiring, the relationships, the graph of your objects and how they relate to each other. We've also got, the core root actuator endpoint, which is where we are right now. All right, so we talked about all the big ones in brief. Let's double click on a couple of those. First, the info endpoint. The info endpoint is a great place to add information that you can use to identify the service in production. So in a typical
continuous delivery context, you'll make a change, write your tests, prove that it works on your local machine, git commit, git push. It'll go into a CI environment, and then eventually to a CD environment, and that'll get deployed to production. Now, what if something goes wrong? Obviously, you've done all that you can to prevent or forestall bugs arriving in production, but it does happen. I mean, it's just natural, right? So if it happens, you want to be able to identify what version of the code contributed to that issue. So one thing you might do is give your microservice a name, right? So you can say info.name equals, and a very good convention is to give yourself Spring application name. And so my Spring application name will just be customers, right? So I'm going to say my info.name is equal to customers, right? And this info dot is arbitrary. Info.message equals hello, right? Hello info.name. It's completely arbitrary. You can specify anything after info dot, and it'll get consumed or absorbed into the output of this endpoint. So there you go. Okay, that's one thing you might put there. You can also put information about the Git build that you are looking at, right? So I'm going to go to the parent of this Spring Boot application. I'll find pl.gitCommitID and go back to my build and just opt in. I don't have to do anything really. I just have to opt in to that one plugin, hit Maven reload. I'll stop this. Maven clean package, skip tests. Okay, it's been packaged. Now let's rerun this. And when it was packaged, it created a file called git.properties. So here's the target directory, classes, git.properties. You can see information like the host on which I ran the build, the email, the username, the version, the commit time, the commit hash, right? So you can do git bisect and things like that. So all that is here, right? And create a Docker file, all that kind of stuff is visible here. I can go to this endpoint, and I can see that's already there. I don't have to do anything. Spring Boot automatically packages that information into the output of the info endpoint if it's there. So this is very, very powerful, because now you can say, oh, okay, this version is the one that was just pushed out last 20 minutes ago. We can fix that. We can just roll back or whatever. We can go to our continuous delivery system and then roll that push back. The other thing that's very convenient that we might want to work with is the health endpoint. Okay, the health endpoint gives you an enumeration of all the different subsystems in the application that, were they to fail, would result in the application being unusable. Right. So if, for example, our file system didn't work, well, actually, this is a poor example because I don't think our code really requires the file system as such. But suppose it did, right? If this was down for whatever reason, or if our R2BBC connection factor were down, our database connection were down, then of course the aggregate status would reflect that. It would say down as well. You can actually contribute your own custom health indicators. So let's say I go back to my application and I want to register my own custom health indicator. I say bean health indicator. Okay, return new health indicator. And the health can be whatever you want, right? I can say health dot out of service, okay? And replace that, restart. So it's always going to return down. So if I go here, it says out of service, and you can see it's reflected here in the output. Obviously, you could connect to or do whatever you needed to. You can say status iHeart production dot build or whatever. And it's up by default, right? But I can say up, so that kind of thing. I can give it a status message as well. Okay, so it's up. Good. All right, so lots of different possibilities here. You can also you can use this configuration with this health endpoint for different cloud platforms, right? So Cloud Foundry will do the right thing if it sees that health indicator.
Azure Spring Cloud as well. Kubernetes has a nuanced concept of health. It has two special endpoints, not just one, and they're called probes. And you can enable those probes by going to application.properties. So we can say probes, health probes enables equals true, okay? And these probes, these are case specific here. And we want these probes to be enabled. So let's go ahead and restart. Now, if you're running, by the way, in a Kubernetes environment, you don't have to specify that property. It'll just be there automatically. But since we're running on my local machine, it says by default it's not available. Okay, so we have got two different states here, liveness state and readiness state. And that reflects the liveness and readiness probe endpoints. So a probe in Kubernetes parlance is an endpoint that you can, that the container orchestrator can pull to interrogate the state of the service. So readiness determines whether the service is ready to be put into production, and liveness determines whether the service is still should be in production, right? Whether it should still be in production. You can control this state, right? You can actually publish an endpoint, publish an event rather, to change that state. So let's say I go here and I say controller class health controller, health rest controller, down, mono void down. Okay, this is a response body. And what I want to do is I want to inject the current application context, like so. And we'll say this, we'll say mono.empty for this, that's actually fine, but say application context, readiness, no, is it availability state, right? Availability, ability, chained event dot publish this dot context. We're going to send a liveness dot broken event. So in Spring we have this concept of an event listener, right? And event publishers, application event publishers rather. So you can publish an event by getting access to the application context or to something called an application event publisher, and that's the core interface. And in fact, application context ultimately implements this. That's why this works. And the publisher has an event. Publisher dot publish event, and there's all sorts of different application events that can be published. You can create your own as well. And elsewhere in the code, you can listen for those events. So you could have like an event listener annotation called, application ready event, right? Class public void ready, right? And when this event is published, any component that registers as a listener will be notified of it. Or you can inject a pointer to it like so, ARE, in which case this is optional. And I can actually now interrogate, okay, well, what is the source? Give me the application context to which it happened or in which it happened. Give me the timestamp, give me the arguments, if any, for this is a custom event, right? This is an application ready event. So in this case, these args are the public static void main string arguments, right? But there's other ones, right? There's a context initialized event, right? I get the application context and whatever. Maybe there's a container initialized, Spring servlet container initializer, whatever. There's just all sorts of different ones, and you can find them by going to application event and looking at the subclasses, obviously. So, after save event, after test class event, application failed event, application prepared event, ready, started, context closed, context started, repositories populated, request handled event. I mean, everything you can imagine wanting to listen to. When was the RSocket server initialized? Has the Spring batch job finished executing event? Has somebody authenticated? All this kind of stuff is here, right? These events are everywhere, and you can listen to them anywhere in your code. Well, one event that can be listened to is this availability change event, and there's actually this very convenient little static thing you can use to publish
that event from around the context. And when this says down, the health indicator that's responsible for that particular probe will also reflect down. It'll see that event and it'll respond to it. Okay, so there it's down, but let's call the down endpoint curl -d http localhost 8080/down -x post. Okay, and now it says down, right? So you can use these different events to control the state of the service. And when that happens, Kubernetes, which is constantly polling this endpoint at some configured interval, will see the state has changed, and it'll need to restart the service, right? It'll kill the current pod and then start it up somewhere else, okay? The question then is, what should happen to the service that's running right now? Well, if you've got a lot of in-flight transactions, the last thing that you want is for everything to just be stopped, right? Or maybe that's the last thing. I mean, it might be that if the failure is so catastrophic that you couldn't possibly fulfill these requests anyway, so what's the point of keeping the pod around just to pay for it? But still, you need to have a decision about this. You need to make a decision about this and care. So the question is, how should the service be shut down? Should it be shut down immediately, in which case you'll get a sig term and then a sig kill in very short succession with no time in between, really? Or should it be killed with grace, right? Using graceful shutdown. Basically, sig term will be sent to the pod, which Spring will see, and it'll start calling the close method on all the closable types and all the disposable bean types in the Spring application context. They will in turn start, stopping anything that they're doing, and stop accepting any new HTTP requests, and you'll have an interval, and that interval, of course, you have to configure in the Kubernetes manifest as well. But that interval allows you to shut down your work and clean up any state that you've got, any in-flight transactions, etc., within a certain amount of time. Now, how long should that time be? Well, you can specify that here. By default, it's 30 seconds. But again, you need to synchronize what that value is with your Kubernetes pod. Okay, so let's say I created a endpoint here called slow. Okay, or better yet, just string. And we'll say return mono.defer or delay duration dot of seconds 20 seconds. Okay. And we want to have just finished, right? What time is it? We want system.current time. Okay. All right, there's our basic reactive stream. Why is that not okay? Mono.delay .map L. Good. Okay, so there's our updated code. Okay. And there you go. It'll give you a slow acting response. So let's restart. And let's now, what are we going to do? We're going to shut down the application, realizing that we've got 30 seconds in which to get work done, and then wait, let's say 10 seconds or so, and then invoke that endpoint and see what happens. Okay, so we're going to shut down the application with this command, graceful shutdown complete, right? You see that it happened immediately, right? Okay. And now let's go here and do the same thing, but this time we're going to request the slow endpoint. And you can see it's spinning 1, 2, 3, 4, 5, whatever. Now let's kill this. And you can see it says waiting for active requests to complete, right? And so this is the behavior that we want. It'll eventually finish in time, and you can see it's still spinning in the browser tab up there. There you go, finished that, and it gave us a response, and then graceful shutdown complete
immediately thereafter because it was waiting for that to finish. As soon as it finished, then we shut down. So the application has stability. You want to shut down in a graceful fashion. This is really, really important in a distributed system based on something like Kubernetes, where your pods might get killed or relocated for any number of reasons. It's not just one time. It's not just a rare thing. As soon as there's a new deployment of the software, you might have to, kill off a bunch of instances of your node. So this is not a bad thing necessarily. It's just the natural life cycle of a distributed system. Okay, having the ability to respond correctly to that life cycle is very powerful. Okay, so thus far, we've got our application. We've looked at metrics. We've looked at the actuator. There's a lot more we could do here, right? We could use a time series database like Graphite or Prometheus or whatever to store information about statistics and to see the evolution of those values of those statistics over time, right? To show a graph. This is one of the nice things is it's like Redis, but over time. So there's an extra dimension there. We could also use a distributed tracing system using Spring Cloud Sleuth. Spring Cloud Sleuth is our abstraction for tracing, and that support makes it easy for us to see the movement of a request across different services. So if you have a request that starts in one service and goes to another and goes to another and goes to another, and something happens on the third hop, then a distributed tracing system like Sleuth and anything that supports that same abstraction will be able to show you where that happened. And this is very powerful in a distributed systems context, right? Because there's a lot of moving parts. Things are going to fail. So you can use something like Google Cloud Stack Driver Trace or Microsoft Azure or Zipkin or whatever. They are all good, distributed tracing systems, and you can talk to them from Spring Cloud Sleuth. These are two different systems, however. Prometheus is not the same as Zipkin. So one thing that I like about Wavefront, which we talked about earlier, is that you can get that information from both sides, from both metrics and trace information in one unified screen, one console, one place. And it's easy enough to get started with Wavefront. Obviously, this is a shameless plug, but only because I don't like having to deal with this stuff, and it's actually really easy. So just add the dependency management section and add Wavefront to your dependency. And it'll when you restart, it'll show you a well, here, let's just do it. Go here, go to the build. Gonna go down here as well to the dependency management section. Add that in, Maven reload. Oh, we need the property as well, don't we? So wavefront.version. Okay, let's restart this one. Okay, so it took a little bit longer to start up this time because it had to negotiate a new dashboard for us, which I think is really cool. So here's my API token. I can just log into this now, and I can log in with my, I can create an account, right? I can go visit my dashboard here, the one that was just created for me automatically. Okay, got it. So this is a free offering for Spring Boot developers that gives you 50 points of metrics per second, up to 25 different spans. So each trace can have 25 different hops. That's very, very good. Right? Hopefully you're not gonna have 25 different spans in any single request chain, right? It's possible, but hopefully not. And if you do, then hopefully you've got enough that you can upgrade, histograms up to 10 distributions, 5 days of retention data. etc. So okay, good. So there you go. It's already configured. We don't have anything particularly interesting happening in our application just yet. So go to the slow endpoint requests, go to customers endpoint, refresh, 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 refresh. And then eventually that information will percolate into this. This is happening behind the scenes. Hey, Spring Booter. Oh yeah, look at that. There's even a little introduction video here, snooze. Okay. And I know. Configuration is a loaded word. I get it, especially in the context of a Spring application. You're probably all configured out. But in this case, when I say configuration, I'm not talking about the wiring of my objects. I'm talking about 12-factor style configuration. That is, configuration that's specific to a particular environment. The 12-factor manifesto was created by Heroku in the late aughts or early 2010s, one forgets, and it defines a set of principles that make it easier to run and scale applications in a turbulent cloud environment. One such principle is the idea that configuration that's specific to an environment should be just that, environment specific. Things like database credentials, ports, hosts, etc. All that should live outside of the application and in the environment, so that way if I move the application from one environment to another, it can still work. It just has to pull in the configuration from that environment. This is as opposed to having it embedded in the application and necessitating a recompile for each new environment. Let's take a look at some of the possibilities here. Configuration. Configuration is very important in a Spring application. First of all, because it's a loaded word. In this case, when I refer to configuration, I'm not referring so much to how the objects in your object graph wire together, but more to environment-specific strings, things like your credentials, your hosts, your ports, your whatever, things like that. And configuration is something very important. The 12-factor manifesto, which was espoused by Heroku way back in the day, I think like 2008, 2009, set forth 12 principles that cloud applications would do best to follow so that they can be designed in such a way as to be resilient even in the face of the volatile sort of nature of a cloud. So when things get shut down or processes are killed or whatever, the 12-factor manifesto helps give us guidelines to build architectures, to build applications that do the right thing on those platforms. And one of those tenets is the idea of 12-factor style configuration. That is to say, environment-specific configuration should live in the environment. So in this section, we're going to look at different things you can do to make your application do the right thing in different environments. All right, so let's build well, we're not going to build anything. Let's first take a look at our customers application. Our customers application has a property file, and you saw that. Did you know that you can also create a YAML file, right? Application.yaml is also supported out of the box, so you don't have to do anything special. You just create one, and server.port becomes 9191. You can't have two, by the way. You need to either application YAML or application.properties, but you can do it. That's one thing. I'm a big fan of the hashtag no YAML movement, so you won't be seeing me do that very much unless I'm doing Kubernetes, in which case I'll just be up to my eyeballs in YAML. But it's a thing. So okay, we've got this property file, and we can put configuration values in here. Arbitrary ones that are related to certain things that affect the behavior of the application, etc. So let's suppose I wanted to create a controller response body class message rest controller. All right, and I'm gonna have an endpoint here called message string get message, and in order to get that message, I'm going to inject the Spring Framework environment abstraction. Now, the environment abstraction came out in Spring 3.0 way back in 2009, and the core concept of the environment abstraction is that you have a dictionary that you can use to look up keys and values that are germane to your application. So anything in this property file, for example, Spring application name, I could have also passed as a key here, and I could have gotten that. But let's just look up a property called message, okay? So message equals hello customers application dot properties. Okay, so we have a property file there. We can run this application, and we'll see that same message. So let's go ahead and run this. All right, there we go. We go to localhost 80 80/message, and we get nothing, absolutely nothing. And the reason is because I forgot to unset a host and port somewhere, didn't I? Let's see here. Oh, right. Okay. Let's restart this. All right, there we go. So hello customers app, application.properties. All right, good. So we have a value that we're able to read from the property file. I can externalize this value. It might be the case that in my dev environment I want one message, and in Q&A I want another, or just maybe the rules are different. Maybe you have canary builds. Maybe you have whatever. I mean, there's all sorts of reasons why you might want to parameterize a configuration value, right? So one thing I can do in a static way is to make that configuration based on external factors, like the program arguments that I just hinted at there by accident. So message equals hello program argument properties, okay? And I want this to be one string, okay? Apply, okay, restart. Okay, restart, and there's my program arguments properties. Okay, good. So that's one way we can get configuration into the system. Another is to use environment variables. Now, environment variables are actually my preferred way to do it because they're easy to set up in scripts. They're easy to set up in script, and you don't have to change the incantation of the thing that runs the Java program. So, hello environment variables, right? Like so. Apply. Okay, run. Refresh, and there we go. Okay, so we have environment variables, and the environment variables are, that's usually enough. That's a lot for a lot of different use cases. That might actually just be enough. So you might have noticed that I used capital letters there, capital MESSAGE, but I can also specify other environment variables. Let's say I wanted to change the host and the port, so I can say server_port equals 8081, huh? Okay, hit OK, hit apply, hit OK, restart. Good, so there it says 8081. So what happens is that Spring Boot normalizes different environment variables. It normalizes server_port into server.port, lowercases it, and then applies it, and that overrides the default built-in server.port of 8080, right? So this is one of the things you can do to make your applications easier, more easily relocated. You can have a set of default configuration. Maybe in your dev environment, you have a Docker image to which all your developers communicate. It's running on your local machine. It's great for testing your databases and message queues and whatever. But in production, you have environment variables that override the connection query, the connection URLs for your database or your message queue or whatever, right? And you don't have to change anything in the code. You can just literally selectively override values in the code at runtime when you're literally running the application in production, right? Docker has support for this. Kubernetes has support for this. Cloud Foundry has support for this. Azure Spring Cloud has support for this. Heroku has support for this. Everything has support for overriding environment variables. It's a very natural way to communicate process and environment-specific configuration. So it tends to end up in run.sh or some sort of script that gets invoked as a result of a lifecycle change, like the container's been initialized or the pod's been initialized or whatever. And that's hard to track down and centrally change. So let's look at a different approach, which is to use configuration that lives in the deployment itself as opposed to in the container itself or container adjacent. If you're doing Kubernetes, it's very typical to express configuration as config maps, right? And these config maps are keys and values or secrets, right? There are two different resources that you can find in a Kubernetes cluster. A config map is just a dictionary. It's a key and a value or a bunch of keys and values. The keys can be whatever you want and the values can be whatever you want. It's easy to take a config map and connect it to your pod in one of two different ways, either as a volume or as environment variables. So you can take the config map and turn it into environment variables, and then what I just showed you would automatically apply. Or you can take the config map and expose it to your pod, your running application as a volume. And a volume in the Kubernetes world is like a mounted directory full of, in this case, a tree of configuration values and their contents, right? So we call this a config tree. So we can actually import that. Let's say we're inside of we want to import configuration from a Kubernetes config map. I can say I want to get file home desktop config. That trailing / is so important. Do not forget that. You will regret it otherwise. It is not great. Okay, config, cd config, echo, let's say 9090 to server dot port. All right, cat server dot port. Now let's restart this. And again, if everything goes to plan, we're going to import this Kubernetes config tree, which is at this URL here, file, localhost, whatever. Whoops. Did I do something wrong? Maybe I don't need the file bit here. Let's just try this. Okay, there we go. So now this doesn't work because the property is at 9090. So we go here, we say 9090, and voila. Okay, so that's working great. It's at port 9090. We overrode the config value. We could actually say echo hello config tree to message, right? And restart this. Go to the browser. Hello. What was the message I put there? The message that we have. Oh, I have a environment variable. There's a cascade. There's a hierarchy here. So you got to make sure that one doesn't stomp on the other. Remember, the goal is to make it so that the most external thing overrides the more internal thing. And I guess that one. Okay, good. So there's hello config tree. So you can see now, there's a lot of different ways to plug in values. But again, this tends to end up as a sort of a number of strings strewn about your Kubernetes resources, your Kubernetes YAML files, your shell scripts, etc. You can, in theory, you can plug in your configuration and connect it from something like HashiCorp Vault. That's an idea, right? You can actually use all sorts of different things to store your configuration external to your application. But what we want is some way to connect it to our application. Thankfully, the environment abstraction, the thing that we're using here, this environment abstraction, is the foundation for all the different solutions that relate to configuration. The environment supports a chain of strategies called property sources. These property sources talk to different configuration repositories. And so when I ask the environment for a message, it goes to each one of these property sources and says, hey, can you give me the value of message for this different property source? And it does, right? It gives you the different value. Those property sources are flexible. You can add your own. You can actually create something called an environment post processor. It's a class that you would create and then register in the spring.factories text file, right? It would be a meta-inf spring.factories text file with the key equal to the name of the class, which is environment post processor. And that will get initialized before the application startup. And it'll give you a chance to register your own custom property source. And you can do all sorts of things like that. You can register a property source that talks to whatever. But you'll find that most of the time you don't need to do that because we've already got them. So if you want to talk to HashiCorp Vault, which does encryption, right? It does at-rest encryption of keys and values. Then you can use the Spring Cloud Vault project, right? If you wanted to talk to Zookeeper, Apache Zookeeper, you could use that. There's a Spring Cloud config Zookeeper module. If you want to use HashiCorp console, if you want to use any of a number of different things that support configuration, we probably have an implementation that you can use. But those are still, external systems. If you want something simpler, lighter weight, and you just want to store things in Git, and you want to have full access to the auditability and version controllability of a Git repository, then perhaps you should check out the Spring Cloud Config Server. So what I'm going to do is I'm going to go back to start.spring.io, and I'm going to build an application here called the config server. And here I'll add a config server dependency, make it Java 17, hit generate, and I'll open this up in my IDE. And what this does is downloads UAO. Did I download 2 of them? Let's try this again, make sure I got the right one. Okay. What this config server is going to do is it's going to act as a repository for configuration. So we'll say enable config server, and we're going to say that we want to run this on port 8888, and we want this to in turn talk to a Git repository that contains configuration values, and that config repository is in the Cloud Native Java deep dive or GitHub org. And I've got a directory here, a repository called configuration. I'm going to take that and I'll say URI equals this, right? So Spring Cloud config server URI equals, or Git URI equals this. And in that Git repository, I have 2 property files, or 2 different files, application.yaml, which all microservices will consume. And I have client.properties, which only the microservice named client will see. So let's start this up here. And I think this microservice is actually called customers, isn't it? So I need to change this client.properties to be customers. I can change it, customers. Okay, save, commit changes, et voila. Okay, and the message is hello cloud native. So now I want to add the Spring Cloud config server support to my customer's microservice. In order to do that, I need to go back to the Spring Initializer and add the config client dependency to my application. So let's refresh. Config client, control space. I'm going to add the Spring Cloud dependencies. Okay, this will require me to surgically change this, but if you're smart enough to remember that you're going to need this at the very beginning, at the onset of your project, then you'll just be able to add it at the very get-go, right? So there's that. I need the property for Spring Cloud itself. Okay. Paste. And then finally, I need the Spring Cloud starter config. Voila. Okay, let's do this. Refresh Maven. Reload project. Okay, so now it's on the class path. And this config server, before I actually use it, I just remembered one other thing you should be aware of is that the default Git repository on a GitHub initiated project is main. But it used to be that the default branch was something called master, which is unfortunate, and so they changed it, thankfully, to main. That said, the Spring Cloud config server defaults at the moment to the old standard, to the old common name. So we're going to say default label equals main, right? So default label equals main. Make sure you specify that. Restart this, and then go to the customers application. Refresh this, or restart it. Okay, what did I do wrong? Oh, see, I said that we have to, we added the Spring Cloud config client to the class path, but we haven't specified Spring config import equals config server. So I have this bit right here. Let's also add the config server. Okay, so I don't want the config tree anymore. I want the config server. The config server prefix, it doesn't have to, you can put, technically you can put a URI after this, right? Just flesh that out as you would. But if you specify nothing, it'll look for this property. And by default, this defaults to localhost 8888, okay? So you don't have to specify it, but if you want to know what it is, that's what it is, okay? So it's going to be config server colon and then the value of this. So specify that with the host and port of the config server that we just instantiated, which in this case, as I say, is on localhost 8880. 888888, okay? All right, so this is now back to 8080, isn't it? So here we are. Nope. What did I do wrong? 8082. Okay, so 8082. Very good. There's my message from the config repository in GitHub. Very cool, right? Like I can actually do interesting things with that. You can also change the configuration, right? So I'm using, I can actually, let's say I wanted to change the value, okay? In order to change the value, I need to make sure that I'm using the Spring Boot actuator, and I've enabled all the endpoints, including, and in particular, the refresh endpoint. So now, since that's already done, I don't have to do anything. I can go here to the config repository, change this file. I'll say, hello cloud natives, du, okay? And I'll save the file, commit changes, and I'll say curl -d -h content, sorry, -h is a content type application JSON, HTTP localhost, and we're running on port. What port are we running on? We're running on port 8080. Is that right? I think it keeps changing. 8082. Very good. Okay. Very good. /actuator/refresh. Hit refresh, and you can see that it's indicated that the message has changed on that service. So I refresh this, and it says pop do. Now I didn't restart the application. I didn't do anything like that. All I did was I sent a post to the actuator endpoint called actuator/refresh, and I told it to redraw its own configuration. And you can do just some interesting things with that, right? Like here, I'm just rereading the data from the environment itself. But let's suppose I had an object that had previously injected this value, and it was just already there. So let's say add controller, or actually, you know what? Let's try this again. Let's just say I wanted to cache this value, because it makes no sense to recompute this unless things change, but hopefully they'll never change. They're not going to change all the time, right? So we'll say message, and here we'll say this dot message equals this dot, or better yet, we can environment dot get property message. Okay, get rid of that. Don't need that. And here we'll just return message. All right, good stuff. So there's that. Now I'm gonna, I want this to be reconfigurable. I want to reconfigure this controller if and when something refreshes the configuration, right? I don't want to have to restart the whole service. So I'll make this bean refresh scoped. And the benefit of that is that the object will get created anew in situ whenever there's a change in the environment, okay? So we'll restart this to take advantage of that new refresh scope annotation and the new code. All right. So let's now go here to our config file. Well, first refresh, right? You can see it's about due. But now I'm going to say pas toi, or, you know, in Chinese, 3 is sun. So I'll say commit changes. And you can see nothing has happened yet. But if I reissue that same actuator command, okay, you can see it says sun. So I didn't have to even, I'm no longer doing the expensive thing of reinitialize or rereading that value, because that property source might be making a network call every time you ask it for the message, right? So instead, even though I'm injecting it once, this object, this actual class, ends up being just a proxy. It's a shell, a husk of the actual object that you want. And whenever there's a refresh event, it reinitializes all the objects that are associated with that scope. And this is good because it reinitializes the constructor and it reinjects this, and the value that is given is new. And by the time you get to this endpoint, it's the new value. So we've looked at a number of different ways to externalize your application configuration. That said, you know, this assumes that you've got the same code in every environment. You've just got different values for that code, right? But you might actually have different things. You might have different configuration that applies in different environments. For example, if I'm running in Kubernetes, I might want, you know, different kinds of configuration, right? And so we can do that with 2 different ways. There's 2 different ways to segmentize or add a dimension to a configuration. One is to do a profile. So I can say dash triple hash, right? So get rid of that. And well, that's fine. And then what you say is activate on profile equals. And here I can say when there's a Spring profile called cloud, then I want this configuration to apply. Okay, that's fine. But this requires you to specify a profile. So, and it's not hard. You set an environment variable called Spring profiles active. That'll work just fine. You can say in your run configuration, you can specify a profile right here. So I could say cloud. That works just fine too. Another way you could, create a dimension of configuration is to activate it based on the environment, on the cloud environment. So here, I want to use Kubernetes, okay? So this is a stanza. This whole section of configuration does not get activated unless this activation, predicate activates. And by default, it's not gonna activate. So let's say that the message here is hello, Kate, right? So there's my message. You can see it's redeclared. So it looks like it's a duplicate property key, but it's not actually. And I wish the folks at the wonderful, by the way, I should just say that. I don't mean to sound ridiculous, but the wonderful, amazing, very, very talented folks at over at IntelliJ, I wish they would add support for this because as per Spring Boot 2.4 and later, which is more than a year ago, this is actually a separate stanza. Okay, so restart. Okay, so now I've got this configuration that is active only when Kubernetes is active. So I go there and it still shows the value from the config server, right? The git config server. Of course, it probably would have anyway. I think I would have needed to remove it or choose a different value. So let's actually say server.port. Oops, nope. Let's say server.port equals 8010, okay? So this is gonna override, there's no config value in the config server for server.port. So let's say server.port equals 8010 and restart, yeah? Okay, refresh, nothing, right? It's nothing. And so in order to, it will automatically activate as true. It'll automatically register if you're running Kubernetes. There's some smart default logic in the Spring Boot framework to make that work. But if you want to test it, you want to set the main cloud platform to be equals to Kubernetes. So I'll go here, I'll say edit configuration, program arguments, et voila. Okay, hit refresh. All right, so now if I go to, this should be server.port equals 8010. That's true, right? 8010. And then the message is still this, right? I didn't succeed in overriding that because that comes from the config server, which has higher precedence. Okay, so this is cool. You can actually have configuration sets that are unique to each cloud platform. And by the way, this is something that was easily supported before with YAML, right? If you ever did this before with YAML, this isn't new, but this is a new thing in the property files. You can actually have segmented configuration in property files, which I think is super cool. But the other thing you might want to do is to actually have configuration that's, beans registered per environment. So I could say application runner run on Kate, right? And I can say return system out print line hello Kubernetes. Okay. A. Restart. So when I restarted this, it worked. Let me go ahead and add the conditional on cloud platform, Kubernetes. This will still work because we've got that config value pointed to Kubernetes, right? So hello Kubernetes. Now let's disable the property, hit apply, hit OK, hit refresh. Okay, you can see we only get one of them because this annotation will only activate this bean if we're inside of a Kubernetes context, right? Which is in this case not true. We're not. So you can actually have configuration sets and beans that are environment specific. You can also have a property file called application-cloud or application-dev. So if you have configuration that's specific to a particular environment, like for example, your dev environment or whatever, you could say dev.properties, and so long as you're activating that dev profile, then anything that you specify in here will have priority over anything inside of application.properties. The same is edge services are the first port of call for requests from the outside world intended for your downstream services. The idea is that because all requests flow through that edge service, this is a natural place in which to interpose cross-cutting kinds of concerns, things like security, routing, etc. There are different kinds of edge services, API gateways, API adapters, data integration layers, proxies, etc. So let's take a look at a few patterns to make life easier at the edge. All right, in this section, we're going to build an edge service. An edge service is the first port of call for requests from the outside intended to your downstream services. We are going to build our edge service using my second favorite place in the internet. We're going to build an edge service. We're going to use the reactive web support. We're going to use the RSocket support. We use Java 17. We're going to use Spring Cloud Gateway and Redis, the reactive Redis support. And I think we also want security, Spring security, so I'll bring that in as well. And that ought to do. So this edge service will be a great place to interpose cross-cutting kinds of concerns, things like security and routing and compression and so on. We can do this by opening up the edge.zip. All right, we've got our edge service. Now, there's a couple things we can do here. We want to create one of a few different things. The first thing we want to create is a gateway using Spring Cloud Gateway, and we're going to do that by using the DSL. Now, there is actually a YAML version. You can actually configure this using property files or YAML files or whatever. So you say source main resources application.properties, routes, and you can actually define the routes here. This DSL is much easier to work with when you're using YAML because it's hierarchical. But either way, you can do that and you can store that configuration inside the Spring Cloud config server, and you can then reload that configuration to get new routes dynamically without having to restart the edge service. So this is great for low sort of business logic, low code kinds of solutions where you need to act upon incoming requests in a generic fashion, maybe forward them onto something, proxy them, compress them, whatever, without being aware too much of the semantics of the payload itself. So I'm going to say return rlb.routes.build, and then we're going to build a route spec, and the spec will have a path called proxy, and we'll build in URI. We're going to say that the request goes to localhost 8080 / Now we could say customers, right? That's a thing you could put there. But what we want to do is we want to take the request that comes in and swap out the path. So we'll set up a filter, and we'll use the filter to say the path is now proxy. Because remember, the request that comes in will have a path of proxy. We want to set the path to customers and then send the request otherwise unadulterated, unchanged, onward to localhost 8080. Okay, so that is a very simple gateway. Let's go ahead and see what that looks like. Curl -v HTTP localhost host 9999 proxy. Okay, we're unauthorized. I forgot to disable the Spring security support for the moment. Let's do that. We don't need it just yet. Okay. 401. Oh, I have to restart, I think. Oh, and it's complaining that I didn't set up the RSocket messaging security support. That's a good point. So let me comment this out and this as well. Let me reload. Okay. And I'll restart it. Very good. So there's our edge service. Make the same request. And it said it can't find there's an error, basically. So what's the issue? Oh, I forgot to set up, here's the customer service, port 8080, right? Or is it some other port? What port are we on? Oh, 8082. Okay. Mea culpa. So we go to the edge service here. Restart. All right, very good. So there's our edge service on port 9999. There's our JSON data from the downstream service. So what we've done is we've proxied the request to the downstream service and we've gotten the data back. All right, not such a big deal, but you can imagine deploying an HTML5 client, right? You might want to have your HTML5 client connect to your different downstream services. And so the simplest thing you could possibly do is, let's say, create a single gateway endpoint where you have different routes for each downstream service, right? So when they go to this one, path/orders, for example, you could then send it on to another service. Obviously, in this case, that downstream service is RSocket, so that wouldn't work, right? We'd have to do some sort of translation. So we'll look at that in just a second. But if you have HTTP endpoints and you just want to proxy them, this is great, right? You can do some very interesting things with this filter as well, right? The filter is where a lot of the power comes. You can actually set the path. You can configure retries. You can say, I want to retry 10 times. I want to retry, and then I want to have a retry config, and I want to say RC whatever. And you can set the route that you want to use, the retry, the backoff strategy, all sorts of different things you can do here. We can also do rate limiting, right? So you can say, I want to configure a rate limiter. I can also add headers. I can add an HTTP response header. So HTTP headers dot access control allow origin. I'm going to say allow everything. And then for the rate limiter, the rate limiter has a very simple job. Its job is, given a request, it's to assess whether there's any more tokens in a bucket, basically, if there's any more availability for requests intended for the downstream service. And it does that by consulting a budget that you prescribe when you configure your rate limiter. So the question then is, here's my rate limiter. The question is, how do we do that? Well, we want a rate limiter that'll keep track of requests that have gone into the system and decrement the availability for each of those requests based on some quota that you specify, right? So here I've got a rate limiter that's got a default capacity of 5 that'll burst to 7. The thing that's important here is that this is a Redis rate limiter. Redis is already on the class path. You saw me add reactive Redis support earlier on. And the reactive Redis support is useful because now we can talk to a Redis distributed data store. I've got a Redis instance here. Redis, right? Oops. CLI, come on. Okay, and I've got nothing in it at the moment. And Redis is a distributed data structure server. It has the ability to let me work with data in terms of keys, queues, maps, pub/sub collections, all sorts of different things, right? So Redis is really versatile. Obviously, I recommend it. Check out my Spring Tips video on that if you haven't already. It features Brian Semboden. It's a lot of fun. But anyway, we're going to use Redis here. And Redis is independent of any of these edge services. So even if we deploy 10 of these edge services, I'm going to use Redis to keep an atomic counter. That atomic counter will keep track of how many requests have come into the edge service. And it doesn't matter which edge service. If they're all connected to the same Redis, they'll see the same count. And so if one of them decrements it and the other one decrements it and the total is 10, then you'll have a total of 8 left over. And it doesn't matter what edge service, which instance of the Spring Boot application that request arrives at, right? And this is good because now you don't have to do weird math based on the number of provisioned instances and all that. You can just say, I want a total of 10 instances, or 10 requests rather. And again, I'm using 10 because it's a nice simple round number, but and I'm using 5 here because it's going to be trivial to overwhelm that, which is useful for my demo. But again, you can expect thousands of requests per second, right? There's no reason not to in most use cases. So find the number that works for you, and if you have a downstream service that overwhelms easily and you want to make sure it's fine, then you can cap the number of requests that are allowed through using this rate limiter. So we've got that rate limiter. The rate limiter is it's going to use Redis, like I say, which is a distributed data structure server. It's got keys, and those keys are used to determine the value, to find the value. So you ask for a value by its key, and in this case, we need to give Redis a clue about where to find the atomic number. So we can say, use this new key resolver. We'll plug that in. So we'll plug that key resolver in, and you have a very simple job here. You have to return a string, which is the name of the key. So I can say, Maria la chiave, right, from La Vita Bella. That's one key, right? And that's fine. That's the same key for every request, no matter what their location. However, you might want to have a particular key for a given location. So you can do that. You can say, okay, give me the current request, and then given the request, maybe I can look up things like the locale or whatever, right? You can get all sorts of different things here based on that information. Again, the remote address, the query params, whatever. I mean, you might have cookies in the context that you can look at, and you might say, okay, well, this person is coming from a region that should be asleep right now, and therefore there's not a lot of demand, and so we can go ahead and give that person access to more. But this person is coming from an area where there's a hot sale going on, and we need to limit the access to it because we don't want people abusing the system or whatever. But the point is, you can make that determination dynamically, right? So one thing you might want to do is to say, given a request with a principal, a security, principal, take the principal and then turn it into a principal with a name. And you might say, okay, well, if that doesn't exist, if there's no name, then return empty, right? Which is a very good strategy. It's very easy to write as well. And so this is basically saying each user gets their own status. They each get 10 requests per second or whatever, right? Okay, that's fine. But you can also, if you like that strategy, you can just use the one that we wrote out of the box. And in fact, if you like that, you can just use nothing. You can just don't specify it, and that's the default, and that'll work just fine, okay? So we have our filters here. Let me clean that up a little bit. There we go. We got our filters. We're adding a request header for cores. We're setting up a rate limiter, and we're setting the custom path. So, and this predicate is matching based on the path only, but I can also add other things. I can say, okay, well, the host has got to be spring.io, so path and host has to be, right? And whatever, lots of different predicates here. And if you don't see one that you like, you can just write your own using the predicate of Server Web Exchange or async predicate of Server Web Exchange, okay? So very powerful. Now the question then is, if this is going to require a authenticated user in the context, the question is, where does that authenticated user come from? Who puts it there? And that is, of course, the job of Spring Security, which we had earlier, but then commented out. So I'm going to just reintroduce only this bit because I don't want to get too into the weeds on security here. I just want something basic. And then we're going to establish a user details service, okay? So user details service, return. So I can actually do a map reactive user details service. That's that, and I'll say new map reactive user details service, user dot with default password JLong. I'm gonna give myself permission. Okay, roles user dot build, and we'll say password PW. All right, good. So there's my default password and the default username and so on. So now we can go ahead and we can run this, but this is gonna lock down everything. So everything needs to be authenticated to get through, which will help us with our demo. But it'll be a problem later when we add other endpoints which we don't necessarily want to be secured. So I'm going to introduce authorization. So I'll say authorization server HTTP security. We'll say return HTTP security dot build, and then we're going to disable. We're going to say we want to enable HTTP basic, right? So we use the defaults. We want to disable the CSRF support there because it's a simple demo. We want to lock out certain endpoints. So this endpoint proxy must be authenticated, right? And then everything else has to be, it's wide open. All right, let's restart this and see what happens. Okay, and I know what you're saying. You want to see that replaced with a, there you go. Good, fixed and fixed. Okay, so go to the command line now. Remember, we've got a user, so we're going to say -v to see the details. User is jlong pw, HTTP localhost 9999/proxy. We also need a host header, don't we? So -h host hello.spring.io. Isn't that what I did? So where's my rule there? Yeah, okay. There we go. So if I make that request, what happens? It says 44 not found. -h hello.spring.io 9999 404 proxy. Oh, I need I changed it to customers at some point. I forgot to undo. Neat. All right, so nope, not that one. Okay, take 3. There we go. There's our data authenticated. And as the requests come back, we are given headers indicate how much capacity we have in that given second. So a second that has long since passed to make more requests. So we can drive a little bit more traffic and see what happens if we somehow manage to overwhelm it. Although with only 5 requests per second, it's not going to be hard. Okay. So for example, HTTP 429, too many requests. There's the data, but we got too many requests, too many requests, too many requests, too many requests. Then there's the data again, etc. So I'm driving a lot of traffic per second using just a bash loop, right? Just curl. But that's by design. I want you to see what happens when you exceed the bandwidth or the quota that's been allocated. Okay, well, we should probably stop that. Good. So now we've driven traffic to the service. And we can see that Spring Cloud Gateway is very useful for generic cross-cutting kinds of concerns. One step further might be to use a Kubernetes resource, which manages the sort of the ingress to things into the cluster for you, and then lets you contribute routes via a route resource. And so we actually have a product. It's a paid, non-open source product that is basically Kubernetes, Spring Cloud Gateway for Kubernetes, and you can actually it supports exactly that. It's a resource, so you can deploy it with your pipeline. And that way you have the routes with each microservice, but the global configuration for the cluster lives and is defined just once, presumably when you bootstrap your cluster. Okay, so Spring Cloud Gateway, really, really powerful. I hope you'll check that out. Now, sometimes you might want to have a different view of the data. You want to change or transform or interact with the data in a way that you don't already have the ability to do. So let's support a client that gives us the ability to do that. And we're going to create some records, and a record for the order data, integer ID, integer customer ID. I'm going to create a record for the customer data. This is Java 17, so integer ID. And we're going to say, what is this? JSON property ID, JSON property name, JSON property customer ID, and JSON property ID. Okay, so there's our basic client. Let's create the bean that implements that supports talking to it. And we're going to do so using the reactive non-blocking HTTP client, and we're going to use the reactive non-blocking RSocket requester, which is not a client, because remember, in RSocket, requests can be bidirectional, right? You don't have to, there's no one direction. It's not like the first thing to connect to the other thing is the client, and the thing that responds henceforth is the server. Quite the contrary. One can initiate the connection, but the other one can be the one that starts asking questions. So there's a disconnect there. So we're going to create some beans to support our use case here. We want the RSocket requester dot builder, And we want .build. Okay. We want to specify the host and port. So localhost, I think we said 9191. Is that true? It's not 8181. Ha. For that matter, is that running? We should make sure it's running. Okay. So 81. Very good. And we need a reactive non-blocking web client. So we'll say web client.builder. Same basic pattern you may have noticed. Okay. And then finally, we can implement this. And so we're going to have a few endpoints here. Flux of customer get customers. Return this dot http.get.uri http localhost 8080 customers dot retrieve and then body to data. So customer.class, fine. That's a reactive stream, good. And then from the order data that comes from the RSocket service. So we'll say get orders for integer customer ID, return this dot RSocket requester dot route orders dot CID, customer ID, retrieve flux order dot class. Okay. Good. So there's the orders and the customers. And now finally, the question is, what if these services aren't available? What if they're down? What if something goes wrong? Well, yeah, that's a good point. You want to make your services as robust as possible. And recall what we talked about earlier. You have lots of flexibility built into the reactive APIs. So I can say retry. I want to retry and have a backoff, and I want to have a exponential backoff with an escalating period of interval between. I want to have an on-error resume handler so that if there's an exception of some sort, I can decide what gets returned instead, right? Sorry, that's a flux, I suppose I want. A flux. Or I can say, I want to do a timeout, right? I want to say duration.of seconds, 10 seconds, whatever, some crazy amount like that, right? I can do all these things, but this isn't just an RSocket thing, right? Like I said, it's a reactive thing. So I can add those same exact operators and same exact calls to this. Indeed, you could write a method called whatever that takes a flux of t, and then you could plug in the standard operators that you care about across all of them, right? The standard error handling conventions there. And now you don't need special libraries to do all of this stuff. You don't need Hystrix, don't need Spring Retry, you don't need lots of stuff, right? You just works. Okay, good. So obviously you could go a step further. There is the Spring Cloud Circuit Breaker project. You could use that, I guess. You could also use what is it called? Resilience for J project, right? You can use that directly as well. I mean, there are lots of different options, right? But I'm happy with this. So we've got our customers, we've got our orders for. Let's actually think about this. What do we got? We got the individual streams of the data, but what I want is actually a composite of both streams of data. So I'm going to create a new aggregate type called a customer orders, and it'll take as its parameters a customer and a list of orders for that customer. So now I've got not just the individual data, but I got them both at the same time. I don't have to do the sorting in the client memory anymore. I can actually just rely on the server to give me the view of all the customers and all their orders at the same time. And this is an ideal use case. This is a wheelhouse for reactive programming, because reactive programming makes this kind of service orchestration, this scatter gather service orchestration and composition much easier, okay? So get customer orders, and I want to say get customers. And then for each customer, I want to keep in memory two different things. I want to say keep the customer itself like this. Okay, and I want to keep the orders. So orders for dot get orders dot ID, and I want to collect that as a list. Okay, and then I'm going to take that data, and I'll be given a tuple 2. I'm going to use the tuple to construct my custom orders object. And I've got access to each typed parameter of this tuple. A tuple is like an array where each indexed parameter has its own type. And there, obviously Java doesn't support the the magic you would need to make this a true language feature, but we have tuple 1 through like 8, I think, maybe it's 12, I don't know, but it's most of the time you'll be just fine. Just use the ones that make sense for the number of parameters you've got, okay? So tuple get t1, tuple.get t2. All right, so there we go. So we're actually saying for each customer, give me the customer and the orders for that customer as a list, and then turn that tuple that comes from the zip operator into a customer orders, and then return a stream of those customer orders as they're being constructed from data coming from an RSocket service and from an HTTP service to the consumer. And the consumer doesn't care that this is actually, I'm making one call to the customer service and then n calls to the order service, right? This is the worst case scenario if you think about it. You don't want to do n+1. In this case, it couldn't be avoided. Although, really it could have, right? You could have built the order service to take a collection of customer IDs. Therefore, you'd have 2 requests, all the customers, and then another request to get the orders for a collection of customer IDs, right? But my point is, even this worst case scenario isn't that bad because those calls to the downstream order service are reactive. That is to say, they're happening concurrently. So I'm making a request for all the customers, and then at the same time, I'm launching n threads or n requests to get the order data. So I'm not waiting customers plus n, the time it takes to get n different orders collections for n orders. I'm waiting, 2x, right? I'm waiting for the customers and then the slowest of the orders times, which is great, right? This is N1, right? This is the kind of performance you want. Very, very, very useful to have this in such an easy way. I don't see a single thread in here, not a single countdown latch, not a single cyclic barrier or runnable thread or execute or anything, and because it just works. Reactive APIs makes writing the correct code and the most performant and scalable code easier as well, right? This is actually the easiest code to write to achieve what we just did. It's the simplest code you could write. It's trivial. So we've got this client. Now let's use this to create an HTTP endpoint so we can see the data. So at controller, at response body class, CRM client REST controller, at get mapping, COs, publisher, customer orders, get customer orders. And we're just going to inject the CRM client here. Private final CRM client. And voila, we'll say this dot CRM client dot get customer orders. And voila, let's just restart this and see what we get. Okay, so 99.99 COs. Just the wrong endpoint. 99.99 COs. Did I break something somewhere? Edge. So it's I'm going to remove the operators because I didn't put anything meaningful there. And so it's actually swallowing the exception. Restart. Oh, it's 8082, isn't it? I can already tell you what happened. Restart one more time. Okay. There's the data. Let's restore our operators because they don't hurt anything. They just made it. We would, if the request had. That's why we timed out, and that's why we got a default error instead of like a big stack trace, is because the operators absorbed the error. Okay, so there we go. There's our data, 1, and then orders, right? So we've got the customers and the orders, each one, right? Customers, orders that are adjacent to each other, they're next to each other. You can see that this customer has an ID of 3, and the customer ID is 3. So we're actually we're doing a scatter gather kind of service orchestration composition. Now, reactive programming is perfect for this kind of stuff. You can easily create new views of your data for your different clients. And this is going to happen a lot, right? As you introduce more clients, they'll have different needs. And you don't want to make each client figure this stuff out because they're going to have to make a call to downstream services. And in this case, it would, you'd have to add redundant authentication and authorization to both the RSocket and the HTTP service, which you could do, certainly, right? I mean, RSocket has a Spring security integration, as does Spring Webflux and Spring MVC. So you could do that, but why? Why bother? Why not just have one layer for authentication? That's the gateway or something at the edge. And then route the request downward. The other thing the client would have to do is to speak RSocket and HTTP. And they would also have to deal with the potential latency of whatever client experience that they have. So if you're an Android client or an iOS client or a web page or whatever, there's no telling where somebody's going to be making that request. They might be passing through a tunnel on their mobile phone when they start asking for that data. And that means that they're going to be waiting for all the customers, and then finally at the same time, hopefully the order data, and they have to make those calls. We can make lots of calls at the same time on the server side, but the client, no, not so much. It's not free to create threads and to do that kind of stuff on the client. So this is a much better experience for the client, and the client gets what they want. They get the view of the data that they want, and everybody's happy for now. But that's the problem, isn't it? That as easy as reactive programming makes building these custom views, we'll never ever be able to out maneuver the clients. They're always going to have some new scenario that they need cared for. And so while we've worked really hard with Spring Cloud Gateway and reactive programming to make this kind of stuff as trivial and lightweight as possible, it's still work. It's still something has to be done. Somebody has to do, and what we want is to make it so that the client can help themselves, if at all possible. And this is the tension that Facebook was facing back in 2012. They wanted well-isolated individual microservices that had their own APIs and their own data, but they wanted the clients to get the data as quickly as possible. They didn't want to have inefficient round trips to the server, and they wanted to get the data that they needed and no more than that data. They don't want to pay the cost of loading all this extra data over the wire when they only needed just a little bit of it, right? So in both cases, there's a bit of a tension here between what the architecture of the backend required and the architecture of the client required, right? And so they created something called GraphQL. Now, GraphQL makes it trivial to build a data integration layer that is sort of, self-service. You can actually ask for just the data that you want and no more. And we have a project called Spring GraphQL. So what we want to do is we want to add support for GraphQL. So I'm going to go back to my build, and we're going to go to the initializer. We're going to add, let's say, milestones, hit explore. I don't actually want the milestones, but I want the milestone repositories, and this is a convenient way to get them added. Paste those in there. And once I've done that, I can manually add the GraphQL Spring Boot starter. So I'll say, and I want M2, very good. All right, let's re-import this. And now in my build, I have to create a GraphQL endpoint. Now GraphQL is schema-centric. So you create a file here, a directory. We want to call it GraphQL. And we create a file. Okay, a new file called schema.graphqls. And in there, you, by convention, always create a type called query. You can create objects in the schema, and these objects have fields. These fields are the readers or the accessors for data. But they can also act kind of like methods in that you can pass in arguments that can be used to filter the data that gets returned when you read those fields. And the root of all the types in all of GraphQL is query. That's where you will see all the endpoints that are available to you. And so suppose I wanted to create an endpoint that gave me all the customers. I would describe the customer as having an ID field named ID with a type called ID. You could use something like int or something like that, but ID just means this is a primary key for this type. It's special. There's also the name field, which is of type string. And I want to support returning a collection of customers. Well, a single value would just be like that. But if you want to do a collection, you have to specify bracket, okay? That's the customers. I can also have an endpoint here for orders, let's say, okay? So orders
type order ID customer ID. And you might say, well, I might want to have orders by customer ID, right? So customer ID. And you could do that, and that would actually give you back a view of the data. You're providing a parameter that would dictate how these results are returned or filtered or whatever. And that's fine, but that would get us back to where we are right now. One of the really interesting possibilities here is that you can have the thing that provides the value for a given field on any object be dynamic, right? So let's say I have my customer type. I also want to have a collection of orders that live on that customer. So rather than doing scatter-gather kinds of service orchestration and composition, I have one root type called customer, and each one returns 0 to n orders. Okay, so this is my basic schema, and I want to now implement the controllers to respond to that schema. So I'll go here and I'll create another controller. You've seen me use controller for REST. We could have done MVC or WebSockets. We've also seen it used for RSocket, now for GraphQL. So we're going to call this the CRM client controller, and we're going to inject our CRM client, put that in the constructor, and we're going to have some endpoints here. Now recall, we have a schema, and we have to provide values for the fields in those schemas. So the way you think of it is I'm going to have a mapping for a given type called query, and the field in this case is called customers, right? So customers. I'm going to return a collection of customers for that use case. So crm.getCustomers. Now, turns out that this is such a common use case of having a field resolver. This is we call this in the underlying implementation. Remember that Spring GraphQL is the spiritual successor to the GraphQL Java Spring integration. In the underlying implementation, there's this concept of a data fetcher. A data fetcher is a type that you can use to fetch your data. And in the underlying implementation, you say, I want to create a data fetcher for this type, and then you provide a data fetcher, which is the thing that actually, when asked for the data for the string customers field, produces the objects that belong in that field, right? And this is such a common thing that, in fact, if you're creating an endpoint if you're creating a resolver or a data fetcher, or in this case, a controller handler method, in the Spring parlance, for the well-known type query, then you can use query mapping, right? So you don't need this anymore, it's redundant. And you can say value equals this, but you don't even need that anymore either because it's implied by the name of the method, okay? You will, on occasion, find yourself using schema mapping. So for example, what if I wanted to resolve the orders, right? We know that the customer data, when it comes back, will have the name and the ID, but that's not the same as the orders. That doesn't include the orders. It's in the GraphQL, but it's not in the object model itself. So what I'm going to do is I'm going to create a schema mapping for orders for the type named customer. So publisher order. Now again, I'm going to need the root type, aren't I? I'm going to need the customer in order to be able to inform the call to the order service to get the orders for that customer. So you can inject the root, you can inject the type here. The type whose reference fields you're returning thusly. So you can say this dot crm dot get orders for customer dot ID. All right, and there are other annotations here. If you want to do mutations, then you create a type called mutation, and you provide the handlers for that as well. So I could say, add customer, and I could take an argument, and the argument is the name. So this would be, you'd do something with Spring Data here or something like that to add the data, right? And you would just add this to a well-known type called mutation. And mutations are how you add or change the state of the data on the server. So name string returns a single customer, right? So that's a mutation. That's how you would add or change the state of the system on the server. And there's no dogma here. There's no is this post or put? Do I use 201 or 202 or 200? Do I return a status for the location? It's a mutation. There's only one way to change things on the server. It doesn't matter whether you're updating or idempotent or adding. It's the same thing, right? It's very, very simple. There's no, you can't be wrong on this. Either you're doing a mutation or you're not, right? And this is one of the nice things that's refreshing about GraphQL is you can just write the business logic. Just focus on getting the software that works into production so that your clients can use it, right? There's another kind of mapping called a subscription mapping. A subscription mapping is used to return data over time. So center data, stock ticker data, feeds of some sort that go on forever. This is great subscription data is great if you want to ask the question and get the responses in a trickle over time. Okay, so we've got our basic GraphQL handler, our controller. We've got our schema. Let's go ahead and restart this and see what that gets us. So we can go to localhost 9999, and the Spring Boot starter automatically installs a console that we can use to interact with our data called GraphIQL, not S. Okay, so we can use that here. We can say, okay, I want to issue a query, and I want to get and by the way, notice that we have types here. We can just control space. It's automatically introspectable. So I can say I want to get the customers back, and you can say I want to get the customers back by with just the ID. Great. Okay. What about the ID and the name? I want both fields. Okay. Hit enter. Good. I got that. I don't have to get the data I don't want. So if I want to get the orders, I can, but notice that it's a complex type, not just constituent, primitive types like strings and integers. So I need to specify what fields I want out of that as well. So I can say, you can see it gets pretty ugly. You can actually prettify things like that, and you get the same data. So I am making a call to the order service. I'm asking for the IDs and the customer ID, right? Fine, right? But if I don't want the order service, then it doesn't get involved. The resolver for orders data doesn't get run. I'm not paying the network cost to make that call to the downstream order service via RSocket. I'm not paying the cost of the N+1, right? It's just better. So I can use, if I just need the customer data, I just need an overview page with with overview results. This is how you do it. If I want the details for each particular record, then I can get that as well. And it's the same endpoint, same client technology, same everything. I don't have to change anything else. I love this about GraphQL. And by the way, this is a query, right? Like I said, if you see if there's nothing prefixing this, then you don't have to specify anything else. You can also do, like I say, a mutation. So mutation, that's not a mutation. We have subscriptions and so on, okay? Okay, so good stuff, right? Really, really powerful. You pay for what you use and no more. Very, very flexible. The consumer can get whatever data they want in whatever shape they want, and they don't. And if they want to pay the extra cost of making that call, they can, but they don't need to. And nobody on the server-side team needs to change anything to make it work. Good stuff. Okay, that's been a look at how to build edge services. Obviously, we've just begun to scratch the surface. But there's a lot of potential here, and I think you can see that the opportunities here they range from as light touch and declarative and simple as possible, all the way to more robust, more capable, more powerful, albeit more involved solutions like Spring GraphQL. Well, my friends, that about wraps it up. I think we've covered a few things just to get you started on your journey to production. We've looked at basics, we looked at reactive programming, we looked at the observability support, we looked at building microservices and helping them communicate with each other. We've looked at how to get applications into containers, and into native images using GraalVM. And through it all, we've done so with the eye towards building systems that do the right thing in production. I hope you got something out of this. As always, I'm your friendly neighborhood Starbucks man on Twitter @StarbucksMan, and I'm happy to engage. So if you have questions, don't hesitate to reach out. I'm there for you. Thanks so much for coming. Have a wonderful day, And hopefully we get to do this again in person someday, sooner rather than later.